Hello and welcome back to the second day of this student-led conference discussing perspectives on perception and consciousness, from biological to computational approaches. We're very happy that so many people signed up for the conference with over 450 registrations. So thank you to everyone for joining us today. As Sina mentioned yesterday, we had originally hoped to host this conference in person, but obviously that wasn't possible for obvious reasons. However, this has enabled us to bring together an international lineup of speakers. I'm just going to share my screen and introduce you to us all. So, the conference has been organised by students on the Leverhulme funded Sensation and Perception to Awareness doctoral programme. Part of our programme is to organise an annual conference, and this year's conference is organised by 7 students from cohort 2. There we all are. And overall, we are 21 students divided into 3 cohorts, directed by Professor Jamie Ward and Professor Anil Seth. Our group is an interdisciplinary bunch, which includes students from neuroscience, psychology, robotics, and the arts, and as such, the speakers we've invited and the topics we've centred the days around are our attempt at finding a middle ground or a general theme that connects our research. Our projects tackle questions related to sensation, perception, and awareness in humans, animals, and machines. Today, we're exploring how using technologies might best help us to understand and mediate perception, looking to computational approaches such as brain-machine interfaces, human-computer interaction, and medical applications such as biofeedback. We'll also be discussing the ethical issues presented by such technologies. And finally, there'll be a data blitz from a selection of PhD students keen to share their related research. So, as you can see on the screen, the order of the day runs a little like this. We'll have 4 back-to-back 25-minute talks, and that starts with Dr. Emanuela Maggioni, followed by Dr. David Plans, Professor Miguel Nicoleles, and Dr. Timothy Brown. There'll be a panel discussion at 3:10, and we'll take a break at 3:40 and return at 4:10 for those PhD presentations. I just want to give you some quick notes on housekeeping to keep us on time and respectful of the speakers. As I mentioned, this is an international event running in multiple time zones. So we have to be strict with time, so don't be offended if we cut your questions short. And please, as always, keep your microphones off. If you do have questions, pop them in the chat on Zoom, as we are only taking on questions on Zoom and not monitoring the YouTube comments. After each speaker, there'll be a short 5-minute Q&A for any burning questions related to the speaker and the research, but please save your more in-depth questions for the panel, which will be at the close of the day. So moving on to my first speaker, and it's my pleasure to introduce Dr. Emanuela Maggioni. I'll start sharing my screen now. Dr. Maggioni is an honorary senior research fellow at UCL in London. After getting a PhD at the University of Milan, spending several years as a postdoc at Sussex and exploring commercial ventures with O-Widgets, Emanuela now works with Mariana Obrist at UCL, looking at how we can engage our senses through human-computer interaction. Today, Emanuela will be talking about the power of olfaction in multisensory human-computer interaction. So take it away, Emanuela.
Hi, thank you very much, Fiona, for the introduction. And I'm going to share with you my presentation. Hopefully it's all there and everyone can see it. Great, thank you. So as Fiona was just introducing me, I'm very happy to be virtually back in Sussex because I've been there in the last, I think, 6 years, and where I start my research career in human-computer interaction, coming from a background in experimental psychology and cognitive psychology. As you know, today I will try to present you an overview of the type of research we are doing and how we are trying to open up what is the traditional human-computer interaction that is mainly focused on vision and audio, to how we can have multisensory interaction even in the context of technology. And then I will go to give you more deep information on the project I'm running on olfactory interfaces and olfaction in the overall context of digital health, for instance. But when we think about how we interact with technology, we think about a tablet, a computer, and everything, and the main sensory kind of connection and modality that we use are touch recently and increasingly, but even classically we've been using vision and audio. Even though we are trying to push the boundaries in new technology with even virtual reality environments in which we are trying to exploit other modalities as touch that is not just a simple vibration, but can give you some feedback from interacting with virtual objects, thanks to new technology they are now developing and also available in the market. But still, we know it is very limited, and we are all seeing the problems of designing and developing technology that are counting how our human system is working, how our brain is computing information from different sensory modality. Because mainly, I always present, we always focus on this picture of how we interact with the real world is in a multisensory way. When you are, for instance, in a field and smelling a flower, you have so many other different information, not just audiovisual, and the tactile information is not just simple a vibration, but you can have the texture of the flower, the temperature surrounding you, birds like very far away from you, all this mix of sensory overloading you as well, but is what is the reality. This is what our brain is perceiving as a prior reality. And our attempt is always trying to translate the complexity of the reality then with what is the classic paradigm and how we can enhance and develop new technology, trying to reproduce and respect the prior. Our everyday life is giving us and the expectation we are having of interacting with in a real world environment. For this reason, our research group is always trying to push the boundaries of how to integrate this multisensory stimulation and sensation in a context of human-computer interaction. As you may know, human-computer interaction is a field of research multidisciplinary that is trying to bridge the gap and the boundaries between what is art, science of engineeristic and development of new technology and devices, together with neuroscience concept and leading blocks, because usually we know there are some cutting-edge technology they are never going to respect our human perception, because it's just not taking in consideration what is the most important part, that is the user perception. Our lab was before based in Sussex University, as the majority probably of you know. It was the Sussex Human-Computer Interaction Laboratory led by Mariana Obrist, that is now part in UCL of the bigger research group called Multisensory Devices, which is overall representing what is human-computer interaction for deep physics and cutting-edge technology, prototyping of new levitation system and ultrasound and 3D printed metamaterial, through what we are doing. It is research focused on user-centered design, user testing and validation of those technologies. And what we like to define, we work in the space between the computer, the machine, and the human perception. And we define this space in between something called the experiential space. So what is your experience you are going to have through your senses, that is combining both sides, of course. And as I anticipated before, our ambition is try to push the boundaries going beyond just audio visual, and we focus on touch, not the classic touch. We also compare with classic touch like vibration and motors, physical sensation, but what is a mid-air touch perception using ultrasound speakers and a technology developed by a company called Ultralips. And then opening up all the opportunity to have interfaces and interact with technology through the sense of taste. And then I will talk more about smell, how we can enhance the use of olfactory information in interaction with technology, but also how we can enable the use of olfactory information as interaction modality as such. I leave the website of the research group where you can find more about the team and the type of research, and even find all the references on the main research project I'm going to present you today. As I said, for a matter of time, I'm trying to give you a broad overview of what we do. So just give you some example. The main research we have been carrying on was try to combine what is an applied perspective connected to work-life condition. And we had different fantastic PhD student working, for instance, on in-car interaction. Dimitri Dimitrenko, that is still based in Sussex now, is a lecturer there. How we can exploit olfactory information to overcome the cognitive overload of audio-visual information when you are driving. So how we can exploit another modality to train and to learn a messaging system that is using, as I said, not just visual or audio. And the same kind of application we exploited in a real work life tool, Slack. So how we can use smell interfaces and smell notification to reduce cognitive distraction when you are focused on a primary task, and even apply olfactory information and stimulation in a more classic paradigm as the sense of agency. So we studied how we can use different olfactory stimulus with different perceptual characteristic, and even that are impacting the central nervous system in a different way to modulate or enhance sometimes your sense of agency towards technology, but particularly just test on the classic paradigm of the Libet clock. And some example of our research has been on risk-taking, how we can use different taste stimuli like bitter and sweet and compare their effect on our risk perception, and how this can be exploited then in application in real life context. But also we try to develop new sensory interfaces, a novel solution to convey taste perception. And again, this is based on some technology exploiting ultrasound, in which you can have a delivery of micro droplets of taste stimuli that can be liquids, but even solid. This is all a fantastic research that's still going on, done by VEC, that is based in Sussex. It changed the laboratory, but we are keep working on how to improve and how even to introduce multisensory information in this we call tasty float, delivery device of taste stimuli. And this application is seeing different kind of possibility of real life implementation from entertainment. There are companies they are approaching to develop again a new way of interacting with the user, but even then again in digital health, how we can use taste stimuli to modify the perception and relationship with taste for people affected by eating disorder, for instance. Then another research project that was combining classic paradigm from cognitive and neuroscience, and how we can use this ultrasound technology, not this direct touch, to stimulate body perception illusion and verify and transform classic paradigm as the rubber hand illusion in virtual reality using this kind of technology. And it was all a project done by an ex-colleague, a PhD student finished last year, Dario Pitera. And also how we can create technology that are able to implement and support sensory substitution and opening up accessibility mainly for visually impaired user. There were different type of research, and even a PhD working how Daniel has how to use tactile information, and specifically this not direct touch, to convey scientific communication information, and how to open up again the possibility of inclusion when you are designing and when you are using technology with a broad variety of disability in the users. And then latest but not less important, all the research topics are carried directly from our head of the lab, Mariana Obrist, on new taste interfaces and how we can create taste stimulation. They are using 3D printing technology and materials to explore how it will be, and it is the taste experience in space, in the absence of gravity, and so on. But as I said, today I would like to go just a bit more deeper in what is my research topic, which is what I've been investigating since the beginning of my PhD and even before, and what I'm keep now doing, combining both the academia and even this combined spin-off from the university that is in any case leading to research academic publication as well. So the very first question when we start to think about the sense of smell with technologies, like why we care of using sense, this kind of complex sense in which we cannot control the stimulation and is so complex, so subjective. The very reason is because the olfactory experience is so rich. It rich on a different level of other sensory modality. What I like to define is such a sense that it doesn't require a conscious activation of, like, you are just smelling something that can be below your threshold, but still is impacting your central nervous system, even though you are not aware of that. Is true as a very strong personal connotation due to the link with the long-term memory, and is not passing through what is the thalamic path of decodifying the stimulation, meaning that you can have a not conscious perception of the odors, but you have this so-called Proust effect, the connection and the trigger back of the very first time you've been smelling chemicals for the first time. Even though you are unable to define what was the chemical, you can recall the overall environment or emotional engagement you had with the stimulation. Let's say we know even research of understanding the type of receptor, how the receptor working, how we can digitalize the sense of smell is a very beginning. It's an extremely complex research field, and we are aware of that. But what we try to do with our first project was a European proof of concept funded project back in 2017 was called O-Widgets, try to establish these olfactory widgets. So building blocks from a software component, but even an hardware component, now to exploit all these features and potential of the sense of smell in a way in which they were accessible to a broad variety of users. In the ambition of creating this toolkit to enable the creation of smell-based experiences, really addressing from creative contents, and we had like working with different kind of ambassador. They exploit the technology and they develop a narrative through the smell. They use it in their virtual reality content, but even classic experience in a museum context, through really what we are trying to perceive now, that is the application of olfactory interfaces studies in our everyday life, and how to improve and exploit the power, the characteristic of this sensory modality that is unused when we come to apply to classic paradigm, even in neurorehabilitation. I present here just like a kind of 4 main research area I'm working on the moment, or I've been working in the last year. The first one is really creating this smell space with a theoretical work combining neuroscience knowledge, chemistry knowledge with user experience design knowledge, and try to simplify the complexity around this sensory modality, and give tools and even strategy of thinking how to approach and use smell in different contexts. And then this is a project done by a PhD student, Giada Brianza, still based in Sussex, on body perception, how we can use multisensory information, in particular smell, to modify your body perception and trigger different feelings, and also through also, I would say, modification of the sound, making your body feel it differently and apply this then in context of therapy and rehabilitation as well. And even again in the neuropsychological field, what we've been working on recently is how to translate classic paradigm as the Bell test for neurologic rehabilitation in patient that had stroke, or in any case of visual spatial attention issues, to introduce using it in a virtual reality environment, but also using the olfactory stimulation to attract and train visual spatial attention. This work has been recently published, but what we're using not patient, so a real just samples, laboratory participant, but what we try to do is validate the paradigm and test and see how we can really use this in a real context. We are working with some rehabilitation clinics in Italy on that, and we are hopefully collecting data with post-stroke patient and have ipsilateral lesion of the brain to understand if this can be implemented in a real life rehabilitation kind of process and paradigm. And then something that is another big project which I'm working at the moment is all about using the way in which the sense of smell is impacting the neural central system to personalize relaxation in cancer patient, specifically in breast cancer patient, and understanding how we can create and use a toolkit to enable the using of smell pre-surgery, but even pre-chemotherapy session to reduce the consumption of painkiller, to reduce also the side effect of the chemotherapy and the surgery. And this is an ongoing project with the European Institute of Oncology. And we just finalize it as a review on a journal. I put there the reference if you want to have a look. But this seems to us to be the next level of application in the field of olfactory interfaces, how to enable this personalized experience, which is taking consideration of what is the connection of your personal memories related to smell, and working on a level of enabling to reach the emotional level, but all these neurophysiological effects, the sense of smell, and different chemicals they can have. This is all connected what is our spin out from Sussex University, and now also connected with UCL. It is OW, they stay for O widgets. The ambition is now to digitalize the sense of smell even from a computational side. So we know there is not an RGB for smell. We know the complexity of understanding which chemical they can reproduce which perception. That is a kind of a abstract cognitive representation of the chemicals you are kind of inhaling and activating your receptor. We know the complexity. We are working on an extensive database. We are pushing forward using AI, how we can map different characteristics of the chemicals with different like cognitive representation of the odors. But so far, we've been looking in how we can use a device and a tool, a software tool that is just simplifying the use of the olfactory stimuli, as I say, in different contexts, going away from what is an expensive olfactometer lab-based, so not having a jar of compressor and so on. So we developed at the beginning, back in Sussex, different tiny devices. They were laser cutted and 3D printed, and we went through different phases, and now we have the latest version you can see on the bottom of this slide, that is a tiny device with 24 channels with different chemicals you can also mix and use. And we are working on how to create a nice, even software control to enable, as I said, the use of sense of smell from the digital health technology to the artist to educational and many other field of application. We recently started another ERC proof of concept, just started in June, that has really the ambition of going towards the digitalization of the sense of smell for health application, from the training of the sense of smell and the testing of the sense of smell. This research project is led by OW, but together with UCL. And in between this project, we've been working over I will say the last 3 or 4 years, together with Rockefeller University in New York, to support the first digitalized test of the sense of smell with a project called SmellRS. I left here the references if you want to have a look, how we can apply for the very first time a standardized cross-cultural test of just measuring your sense of smell and give you a feedback, a number, which is a standard number that can be replicated across the world, and we'll have always the same results. Using classic psychophysics staircase, so the device, the technology we develop is smart and adaptive to your answer. So it's modifying the next stimulation, going up and down as a normal staircase, and is giving you this score. The reason why it's so fundamental to finally have a test of the sense of smell is because we need to keep track longitudinally of our sense of smell as we do with our vision, for instance. And because the sense of smell is interlinked as an early onset of neurodegenerative disease, as Alzheimer, Parkinson, and dementia. So even 10 years in advance, we can detect that the decay of this sensory modality can anticipate, meaning that you can enroll patients in early training and support groups, or even in trials with new medication. And as we know, of course, the sense of smell has been the loss of sense of smell and anosmia and all the distortion of taste and smell has been affecting even COVID and long-term COVID. For this reason, we are swapping and readapting the technology to have smell training to facilitate what we like to call a care of the sense of smell with a 24 channel, but even with this little new device we just prototype, which is a bit ugly, but we are working on it. So it's a tiny compact box to have a longitudinal study. So we can give it to single user, they can do their training at home 2 times a day. We develop a nice app, a user interface that is simple, targeting aging population. So how we can really stimulate the importance and the need of training your sense of smell and keep track of even your performance of the sense of smell over time, because we know it can improve cognitive capabilities in aging population and also speed up, in this case of COVID or viral infection, the recovery. But the also incredible part is that we are able now to finalize all the technology and app with a UK Parkinson Association. So we are collecting feedback directly from them, so we can really tailor the technology on their needs and support and trying to improve quality of life even in this kind of patient. Even though we know there is no treatment, we know we can not remake our receptor, they regrow or rewiring, but we can try to slow down the decay of the sense of smell and improve the quality of life overall. Just to wrap up, of course, all of this is always thanks to the research group, the people working in our team, and first Mariana Obrist, but what was our previous Skylab team members. They are present here in our last Zoom call at the beginning of the lockdown. Some are past members, some are still active, some are working with us, but thanks to them, we can do this kind of research and open up so many other future perspectives. And of course, thanks to our founders, because without their money investment, we could not do this kind of research we are doing at this stage. And I just thank you for your attention. If you have any question now, I'm looking forward for the panel discussion. I'll leave all my contact detail. Please keep in touch. We are just establishing the new research team, so we are constantly hiring faculty member, postdocs, or research assistants. So keep an eye, get in touch if you want to be involved. And here there are the website if you want to look and know more.
Thank you so much. What a fascinating talk. Thank you. The research looks incredible. We've popped a link in there to the lab, but of course, you know, if there's anything else you want to put in, please do in the chat. Loads of questions, so I'll just get cracking with those if that's okay.
Sure.
First of all, so from Pasha, we've just got auditory and visual stimuli do not endure in the environment. So how can you disperse smells?
I think it was breaking up, but what I understood, like how we can disperse smell in comparison of how we do accurately with vision and audio. The question is like controlling the stimulation in a very accurate way using like pressurized system and doing also all this modeling of airflow stimulation. So we know how long is lingering the smell in the environment, and you can define exactly the timing of the stimulation, like can be like very short path, so they're dispersing in the environment. So we've done a lot of research on that, and the software, it will allow you to use this kind of modeling. They are somehow simplifying the complexity of doing an airflow modeling live all the time. I just give you some reference point on the duration of the type in function of the type of the chemicals, because some, they are lingering longer, they have like heavier chemicals compound. So it's all a matter of even doing pre-testing if you're doing research application studies, but you can control that as well.
Okay, thank you. And a question from Tess. So Slack is a platform that a lot of us have moved onto during the pandemic, fortunately or not. Could you tell us a little more about how the Associations for Slack project, how you mentioned in your introduction, so just a little bit more about that.
There is a paper on that. It's called Smello Message. So you can find all the information of the implementation from the software side. It was a chatbot like delivering some notification, and what we were doing, we were training even longitudinally the participant to associate certain user or type of messages, like high level importance message, like a direct chat, or low level importance message with a sequence of smell. So it didn't matter really which kind of smell you were using, because the idea is like whatever smell is just a language tool to create association. So we were training this association, then putting the participant in doing a memory card game, and then we were popping up visual notification as a normal banner you have in Slack, and we were comparing when there was a multisensory association of visual and olfactory, or just olfactory. And paradoxically and surprisingly, because you don't need the visual attention to move from your primary task to check the notification, the identification of the sender and the importance of the message was higher in just olfactory stimulation. And we did this over time. So we had a first session, and then after a week we were having a second session. And because of the complexity of this kind of long-term accumulation of the training information was working so well. So I think we see a lot of potential on that.
Great, thank you. Fascinating and terrifying at the same time with the Slack. But,
definitely. Yes.
So I think we've got time for one more question. It's from Bevan. So do you believe that physical stimulation is understood rapidly enough to the brain, or is direct connection required to bypass potential delays, as it would seem that there could be a more significant delay from smell versus vision or touch?
Yes, no, I think this is a big of a generalization. We know how fast the receptor in the nose they can react, and we need to differentiate what is a kind of zero-on reaction of the neurons and the receptor to what is then a mental representation or codification of what you are smelling. There are two different things. So I will never define the sense of smell as the slowest modality, because it's not as such, because the receptor are working as fast as a tactile receptor in hands and so on. And physical, I think probably the question was referring to the middle touch. That is not a physical stimulation. And then, yes, of course, there is a bit of delay between the stimulation and the reaching of the receptor. But as also when we are working with smell, we know there is it can be a delay in between. I delivered the smell in time X, and then in function of the distances of my user, I know there will be a delay. In this case, yes, we need to account for the delay, but we can quantify that.
Great. Okay, thank you very much, and thanks for answering those so eloquently. I think we've got we're going to shift over now to the next speaker, if that's okay. But thank you so much, Emanuela.
A pleasure.
That's really fascinating. And we
see you
should see you
later.
in the panel. Yes, we'll see you in the panel. I'm sure there'll be loads more questions. And there's still links and things in the chat for people that have got inquiries about your work. On to the next speaker. Thank you. And I'm very pleased and particularly excited to introduce Dr. David Plans as my own research. In my own research, I'm collaborating with David, exploring sound and interoception. David Plans was the CEO at BioBeats, an AI startup dedicated to improving mental health through technology, until its acquisition by Human Life Sciences, where he is now the head of research and scientific dissemination. He is also a senior lecturer in organisational neuroscience at the University of Exeter, a fellow of the Alan Turing Institute, and a member of the Social Cognition Lab at the University of Oxford. David's research interests include computational psychiatry, models of stress and emotional resilience, and telemetric approaches to digital therapeutics for mental health. His work involves models through which we might understand the human body's response to stress from a psychobiology perspective, using data from body sensors and smartphone applications to build models that can predict mental disorder. Welcome, David. Nice to have you here. Over to you. Hello.
Hi. I'm not sure I can live up to that introduction at all. It's rather a lot. It sounds a lot grander than it is. I'm just interested in why people burn out and why they forget their bodies when they do, like they forget to drink water and eat. And I'm interested in why people bring food to funerals. Like why do people instinctually know how to do that? Like if you've never been to a funeral, you'll probably be tempted to bring food. And I think that instinct is what I'm interested in, really. The rest of it is just fancy allocations of that interest. And I guess my work at the Alan Turing Institute is the only probably interesting bit, in that I get to work with actual awesome scientists who have real research questions that they've been pursuing for decades. And their modeling is what allows me to entertain this question, such as why does the autonomous nervous system connect the way that it does to stress, and how is that detectable from a computational psychiatry perspective? What kind of verticals in disease are related to this? And how to spot them in real time is something that the Alan Turing Institute is doing within their AI and medicine group. And I guess Huma on the whole, which is the company that acquired us, is interested in remote patient monitoring. So they've seen a lot of data from patients in different modalities, from cardiovascular surgery to bariatric surgery to knee surgery to COVID. And they've been taking real-time data from patients for a decade. And I've spent that same decade taking data from people who suffer from one or other mental disorder, never in major mental disorders until now that I'm working in schizophrenia and others, but almost always in generalized anxiety and depression, not bipolar, but unipolar depression. I have some slides to show you. I don't know if they'll make as much sense as I thought they might, but I'm hoping that it'll work. Can I share screen? Is that allowed?
Yeah, you should be able to do that.
Okay, so I have no icons, so I don't know what I'm opening here.
At the bottom of this, is there a highlighted green at the bottom of the screen?
Oh, it appears I have to, this is a new computer, and it appears that I have to allow it to do that. So give me just 1 second. I promise I'll catch up on time.
Don't worry.
So it won't allow me to do it until I quit. I'll be right back. Okay?
Okay.
I'm sorry about that. I'll be right back.
That's okay. Okay, so we just need to do some bits on our end as well, because we need to make him host again. So 1 second, if you just bear with us.
Okay, that's much better.
Is that okay?
Yeah, I think
Great.
we should be all right. I just need to share the actual presentation, and I'm hoping that'll be all right. Okay, can everyone see this?
Perfect, thank you.
Yay, all right. So So I'll talk about interoception-aware digital therapeutics, and I guess I'll give you a little bit of background as to why. Like, why am I interested in this, and why do I think it's interesting at all? Like I said, I spent about 10 years building digital therapeutics, mostly smartphone extemporizations of things like cognitive behavioral therapy or acceptance and commitment therapy, to try to detect burnout in real time. And mostly I used cardiovascular data, sleep data, accelerometry data, like monitoring movement. It turned out that we could see things like at the onset of depression, people become concentric, they move less, they extend their arms less, their pace changes, their gait and their pitch and yaw change. So it was interesting to see that from a smartphone perspective. And I validated some of those digital therapeutics. And one of those validation studies was in a French bank in London during the Brexit vote, which was awesome because unlike what we expected to see, which was, a sort of Remain vote succeed, the Leave vote succeeded. And although that was gutting, it was even more gutting for all those French bankers in that room whose screens went red completely for weeks on end. And there was basically no sleep and no anything else either. They didn't eat, they forgot to drink, they forgot to go to the bathroom. So we had 3 months of data before that, where it was like normal investment banking stress, which is pretty high, at least in that investment room. And then 3 months afterwards. So it's like somebody had fired a gun in the room and then told everyone to calm down. And that was amazing data to see, because we could see heart rate variability came down. If you don't know what I mean by heart rate variability, it's just measuring the time between heartbeats. When you're really scared, it's really quite similar, and the heart beats really monotonously. And when you're really relaxed, it's really variable and chaotic. It's unintuitive, but that's the way it is. And what we saw was that in that room, heart rate variability plummeted. And as soon as it plummeted, people forgot to eat and hydrate and go to the loo and so on. It also was clear that empathy went out the window. So the moment they forgot to listen to their bodies, they became totally asympathetic. And they even had you could register alexithymia. So they couldn't even see emotion in each other's faces anymore. So they essentially became almost non-human. And I wondered why that might be the case. It turns out that when you look at burnout, and you wonder, okay, I'm a computer scientist, I'm not a psychologist, I wasn't then, I wasn't a neuroscientist, then I retrained. But before that, I wondered as a computer scientist what it was that I was looking at. Why would all these people just, stop receiving signal from the body? And then I looked at Japanese working culture, and they have a word for burnout called karoshi, which quite literally means dying of overwork and starvation. Now, it's really quite something that as a sort of species, we can live next to a supermarket and still die of hunger whilst working, right? And that kind of floored me. So I started to look at earlier expressions of the same, who had looked at this before? And I found obviously, Galen and other people, Roman philosophers, Greek doctors, stuff like that, who had looked at this. The most important of which that I then went on to look at was Robert Burton, who wrote The Anatomy of Melancholy, in 1621. And he'd looked at almost everyone before him. So it was an amazing guide to see how it is that we've looked at the connection between mind and body. He looked at it from the view of Paracelsus, right? In that the connection between mind and body was sort of like a fourth idea, like a common medium, a common tie between the body and the soul. And that disruption of that tie, disruption of what he called that league, led to disease. It was like the common denominator to disease. This is interesting if you look at it from the perspective of the DSM. So having retrained as a neuroscientist years later, and kind of familiar with what psychiatrists used to diagnose disorder, or what they quite wrongly sometimes classify as disorder in the DSM, all DSM disorders have one common denominator, and that's disrupted interoception. It's the only and the lowest common denominator. So I thought, okay, that this must be what we need to go into. It's like how to measure interoception. And what does that disruption cause, right? I mean, my question was, how does that work? How can we look at interoception from a smartphone? But more importantly, what does that mean? Like, what happens when the body becomes divorced from the mind? And what does it lead to? Is it really the common denominator to mental disorder, or is it the common denominator to basically anything else? Tolosanos, who was a jurist but also a physician, looked at it from a very simplistic view. The idea was you have a league between the body and soul, and once that dissolves, the disease emerges. So disease is literally the dissolution of that league. Plato looked at it the same way, right? He thought all the mischiefs of the body proceed from the soul. So if you disrupt that idea of like what the mind perceives, then you disrupt the body. What's interesting is that if you go through sort of the history of everyone quoting each other all the way down to Galen, you see people looking at it from the other perspective, that the soul will be condemned by the body, that if you ignore the body, then the soul suffers. And that's from Plutarch. But more recently, if you look at people who work in addiction, for example, and Gabor Mate works in the East Coast in the in Canada, in Vancouver, has worked with heroin addicts primarily, but also crack and meth and all kinds. For 45 years, I guess 50 years now. When he looks at it, and he famously wrote a book called When the Body Says No, he says, whenever we are prevented from learning how to say no, and in this context, he's talking about sort of life in general, our bodies end up saying it for us. Except that, like Besser van der Kolk said in When the Body Keeps the Score, it doesn't say it aloud. So it says it without voicing it aloud to other people in ways that others can understand. So it says it silently. That interest and what seemed to me like an enormous body of evidence going all the way back to Roman and Greek medicine divides into three areas of research. One is how to tell that it's happening. Two is what to do about it. And the other is how to understand it from a much earlier perspective. So how to be preventative about it. So not be diagnostic when it happens, but try to be diagnostic much, much earlier on. This seems like the wrong order, but it'll make sense in a minute, I promise. So if we begin with just diagnostic markers, we could define interoception, and I'm pretty sure that everyone here will already know what I'm talking about, but bear with me just in case you've not heard of it before. I'm sure you have. Interoception could be defined as the sense of the physiological state of our body at any given moment. And many people argue that it's the starting point of self, the starting point of building a self, of being aware of your own bodily state as a foundational layer to a sense of self. I like to think of it as a sort of eighth sense. It's more, for me, like Paracelsus's fourth soul, the idea that cardiac and respiratory perception, pain, affective touch, all of that, including the need to go to the loo, pain, sexual arousal, nausea, all of that, is connected to a sense of how intelligently we perceive the world outside of the sort of proprioception domain and outside of vision alone. The most studied modality of interoception is cardioception, sense of one's own heart and one's own heartbeat. And it's interesting because if you go back to people like Robert Burton, you see in a chapter called Perturbations of the Mind, where he talks about the pure spirits and how they flock from the brain to the heart by certain secret channels. And now we understand, the vagus nerve and everything else that happens. And if you splay the nervous system out, which only about 2 teams in the world have ever managed to incredibly carefully do, it spreads out and you can see lots of nerves everywhere. But in the gut and towards the heart, there's an accumulation of nerves that could fill, an entire football field. And that's really the intelligence we're talking about, the idea of the spidey sense, in that in the face of danger, in the face of challenges, or in the face of emotions, good and bad, we rely on that intelligence primarily, right? And I guess probably everyone's with me so far, except that when that sense is disrupted in some way, then we have a sense of the world that begins and ends with an intuition that is itself disrupted. And that's when things like generalized anxiety disorder come in, where all input becomes nociceptive. But how to measure it? How do we measure interoception? I began by looking at everything else that everyone had done and to look for effective stimuli for interoception. And it turns out that it's really, really hard to control experimentally. So every measure of interoceptive ability is indirect. So it's a perception of heartbeat or something like it, and mostly lab-based, which was no good for me because it's not scalable. And at the time, I was working with almost 210,000 patients. Right. So people who were using the app that we wrote, there was 210,000 of them. I couldn't get them in a lab. Not that I tried, but it was not scalable. And also, most measures offered pre-selected delays. And that seemed unintuitive to me because they don't account for body location. I already knew that I had several dozen millisecond delays between finger at the pulse in the camera on the phone and the actual heartbeat. I knew that brachial pulse alone could account for delays, but also people have different length arms, people have different shaped bodies, people have different senses of that delay. So none of the tasks accounted for this, and that bothered me. So I couldn't find a truly reliable measure for interoception that could be deployed at scale. So I wrote one. It's called the phase adjustment task, a paper on this with my colleagues and with Sonia Ponta, who was my co-I and a joint first author in this paper. Has been published now at Biological Psychology, where we outline a smartphone deployable task that is faster than those currently available, but it looks like could be more reliable. And I can talk about that in more detail, perhaps in the questions, but essentially the way that it overcomes the issue is that, let me check the time, yeah. So it overcomes the issue by looking at consistency rather than accuracy. So instead of saying, okay, 15 seconds have gone by, how many heartbeats did you perceive? Or by making sound out of each heartbeat and asking you to tell me whether it's in sync or not with your own heartbeat, which are primarily the two types of tasks that were there before. Instead, we ask people to rate their consistency rather than accuracy in matching, we rate their consistency rather than their accuracy in matching the perception with a delayed audio. The way we do that is we give them a volume knob in the app. And we did a trial with 124 participants where each did 20 trials with delayed tones, starting at random. And so the delays themselves were random. And then we asked them where they perceived the delay every 5 trials. And they moved the dial to understand, to the best of their perception, where it would be in sync, like where the delay felt right. We calculate average heart rate in the app itself and we use that to predict the next heartbeat. And they just move the dial to what they perceive as right. The delays are coded as angles within a circumference. And that means that consistency is obtained by looking at angle similarity, which turns out to be really, really reliable. So if you compare the results of our trial with the results of a simulation of, I think, over 100,000 data points, you can clearly see that our distribution differs from random, and you can see the two little hillocks. It's not quite an awesome binomial distribution, but it's quite visible that there are two little bits of people. At the right, you have interoceptives, and at the left, you have non-interoceptives. About a third of the sample is interoceptive, which is consistent with what we've seen in test-retest scores as well. But so, if disrupted interoception is the common denominator of all disorder, is it possible that training interoception could help in mental disorder? And I'm sorry if I was talking a bit fast then, but I was afraid that we wouldn't get there because I don't have very much time. So I'm just going to slow down a tad now, because in this question, there's another embedded question, which is, since interoception is hard, like only about a third of people can feel their heartbeat at any point in time, but also, is cardioceptive interoception the best way to go about it? Even if it is, how can we use potential training protocols within an environment that could help more people benefit from it, as in not only those that can actually feel it. People have gone about it different ways, asking people to exercise before training, etc., so that they get a more a better perception of their heartbeat. I think that it's possible that extended reality mediums like augmented reality or virtual reality could help in that we can then rely on things that are already on the body to capture signal and to be much more immediate and to have much more real-time signal. And that brings me to digital therapeutics, which is kind of where I'm heading at this point with this, whereby the idea is that most things that are out now in digital therapeutics, and that includes, most startups that are offering digital therapeutics as apps, are CBT derivatives, and they simply expose known techniques, right, that are in written form, that are usually done with a clinical therapist in a digital form. But body focused biofeedback driven therapeutics are mostly focused on breathing exercises, and some in high level EEG driven games and stuff like that. I think that extended reality and mobile frameworks that are augmented by sensors offer new opportunities, but they need to be built with the idea of the narrative of the body in the first place. Because we've already learned by building some of these that actually it's very difficult to bring people to a new awareness of what's happening in the body when they're under a level of stress that already divorces them from the signal that they're trying to connect to. So it's really difficult to do that, hence the sort of research we're doing with Fiona on music and others. So this is an example. I've got maybe 1 minute, I think, before I, or not, to
You've
explain
got 5,
this.
you're okay. You're all good, you're on time. You've got plenty of time.
Good. Okay, is there 5 minutes for questions or 10?
It's just 5 minutes for questions.
Oh,
but
okay,
you've
so I've got 5
minutes
minutes.
of talking. Yeah, carry
Okay,
on.
awesome. So this is an example of an acceptance and commitment therapy app that we're prototyping. We validated this already, the efficacy of the app by itself, but now we're building interoception scoring into it. And within it is an exercise that does resonant breathing, and that's 0.1 hertz breathing, so about 10 seconds per full breath. So inhale and exhale, no hold. At that rate, you can see an alignment with HRV that improves heart rate variability. And it turns out, and somebody's done a paper on this really recently that I can fetch if someone's interested, where they've proven that augmentation of HRV complexity also helps interoceptive accuracy or interoceptive ability, essentially. And that's a really interesting phenomenon, right? The fact that if you have a fairly immersive rig, say, that you have somebody do something that by force means that you increase HRV amplitude, then you will, by default, increase their interoception, and that has consequences on their level of stress and their reaction and resilience to stress. And that brings me to the last bit that I wanted to talk about, which is that this is all in the context of a much larger idea. The reason that I want to understand interoception at this level, aside from the fact that there was no tooling for smartphones that I could use, was that on the whole, what I was interested is in figuring out how people burnt out in large organizations. That's actually what my title meant, the organizational neuroscience thing, which is just a made up way of talking about how we look at constructs like empathy, and things like interoception in very large groups of people at a time. So if you have a bad leader, does that bad leader translate to differences in cardiovascular resilience in groups of people, for example? So does that level of toxicity transfer? Is empathy contagious? There's questions like that. So in burnout analytics, I work within the DIGIT project, which is a 12 million pound project that the EPSRC just funded. As a co-I, my work package looks at mental well-being and resilience, and the idea is to work with these people. These partners have agreed to work with us in letting us use their employees as guinea pigs. Some of them have lots and lots of people, like people like Amazon. AWS alone has just a bunch of people. So we're talking about 300,000 people overall. And the idea is to understand, from organization to organization, what does it mean to understand how to preempt mental disorder in a way that comes from the ground signal itself, right? So body awareness and disruption of body awareness, empathy and lack of empathy, and understanding when that wanes, when that is disrupted at very large scale. To me, that means that the future of therapeutics in general needs to understand how multisensory narratives play into next generation biofeedback experiments. My particular interest is obviously mental health analytics for large scale monitoring of burnout, but we're already working with the face adjustment task in eating disorders in pre-adolescent people, in fibromyalgia, in PTSD. I'm forgetting a few now, but there's like several live projects that are already using it in aspects that I'm not a specialist in, that I'm not particularly interested in, that isn't really interesting to me, but that is less interesting to me than this large scale monitoring thing that I do. Thank you very much. I think we can go to questions probably. Am I on time? I think so.
You are on time. That was great. Thank you so much, David. Obviously, very much love your work, and it's absolutely timely at the moment, post-COVID reality that we're in, or whatever we're in now. So starting with the most recent question, so from Kristjan, do you believe mindfulness could also be helpful in training interoception, as it seems that one effect of mindfulness training could be to amplify interoceptive signals? Do you think there is some level of overlap with mindfulness training?
Yeah, absolutely. I have a problem with mindfulness, right? I have a bone to pick in mindfulness. I mean, you can Google me and mindfulness and you'll see me ranting about it. But I think mindfulness is a little bit like Zen was in the 80s, in that it helps people like venture capitalists become even more sociopathic than they already are. So it's like, oh yeah, I'm going to screw people royally, but also I'm going to be really calm about it. Like, it's really quite dodgy, the mindfulness industry can be awful about that, in that they're just helping the worried well be less worried, and they're helping the absolutely ridiculously privileged suffer even less. Whereas actually what I'm interested in is a key principle of actual mindfulness. And by that, I guess I mean the principles and core practices of what you can find in every single core religion that humans have invented. Right, so you can find it in Pali Buddhism, you can find it in Islam, you can find it in Catholicism when you ignore everything else that's awful about Catholicism, and it all has to do with heart-based compassion. So the idea of like feeling for other people, and if that's where it begins, if that's where mindfulness has an idea of how it could help interoception, then I totally agree. But when it is about reduction of individual pain and reduction of suffering, I become much more worried about it, because reduction of suffering cannot come from sheer ignorance of suffering itself. Life is suffering, if you believe mindfulness people, especially. So it has to come from empathy. It has to come from connection to other people. So first you care about everybody else, and then as a result, you get better. And that seems unintuitive maybe, but that would have to be my answer.
Perfect, thank you. Just on to the next question with Carla. So is there a bi-directional relationship between interoception and burnout and stress? I.e., do people who are lower in interoceptive abilities being more susceptible to burnout or stress, but also burnout stress lowering interoceptive abilities?
Yeah, totally. Yeah, there is. And it's, yeah, I mean, the most tragic thing I found out recently about that connection is that in the general population, where you don't account for anything else, but you control for mental disorder and for any other medical condition. So in healthy people, primarily, you will find that about a third of people are interoceptive. If you look at people with fibromyalgia, it's more like 70%, right? So there's a direct connection between diseases where signals from the body is disrupted permanently, like constantly disrupted, because there is a battle, like in the case of fibromyalgia, tragically, one's own breath. So then interoception kind of goes through the roof by force. On the other hand, if you take somebody who is otherwise healthy, but they are really non-interoceptive, you can get people who suffer from burnout much more easily, because they go further as a functioning human being, all the way into clinical depression, all the way into the outer edges of burnout without noticing, and then suddenly they break down, right? But there's a downside to this, which is that people who have really high interoception also are prone to suffering from things like panic disorder more commonly, because they will be more aware of things like heart palpitations, of little pains, of churning in the stomach, of nausea, of breath and stuff like that. And so they can see all those signals as nociceptive when they really aren't. So there's a sort of happy in between where you should aim to be a 7-year-old, right? Where you're still breathing from the belly. You haven't learned social anxiety yet. And I'm not encouraging you to be a sociopath, but I'm saying that people used to breathe from their bellies, and you try to get a 40-year-old man to breathe from the belly. It's like impossible. You can get almost any woman to do it, right? Because they have imperatives that are that men are educated to ignore. But you get a man in a middle-aged man, like a Gen Xer or a boomer, to try and breathe from the belly. It's never going to happen, right? It's literally like trying to teach them Venusian. It's like a foreign language, the idea of relaxing that. So yeah, there is a bidirectional relationship between interoception and burnout, and stressing that they're ultimately related, because once you have that break in, that divorce between body signal and human being, you lose everything else. Yeah.
agree. 7-year-olds for the win. So next question, a final question, if that's okay, David, from Anil, and that's for the feasibility study on interoceptive training, was there an active control condition? And he apologized if he...
Yeah, so we had 2 active controls, and one was a mindfulness exercise. The other one was a really passive condition. We did several validation studies like that, but there was always at least 2 active controls. Yeah. And it's interesting, right? Because we haven't yet done a protocol for interoceptive training that takes into account how to measure it using the phase adjustment task. That's what we're going to do next. So when we did that, we did it using the old tasks. So my feeling is that what we did then isn't valid. That what we saw wasn't actually there, that we weren't in fact measuring interoception, but aptitude to do the task itself. Like if it, and the proof of that is that in one of the validation studies, I made people do the Iowa gambling task. People who were better at the Iowa gambling task also scored higher in interoception, right? And so this is a sort of like guessing game where if you're good at, like, those people who move cups in front of you, if you're good at guessing where that is, then you'll probably be a better interoceptor, but in a fake way, not in a real way, but in a sort of like, I can kind of tell what's going on because I'm smart, like that way. So I think we're going to have to redo all of that if that was the question from, I'm sorry, yeah, if that was the question.
Perfect, thank you. Thank you, David, and thank you, Emanuela, as well. And so we are about to go for a little 10-minute break, get yourself a cup of tea, and we'll be back with my fellow student, Jacopo, to introduce Miguel and Nicolas. So thank you very much, we'll see you soon.
Thank you.
Hello, welcome back. Unfortunately, the other two speakers that we had lined up are not here yet. So we are extending the break for 10 more minutes. Okay, sorry about that. Hello, everyone. Apologize for the inconvenience, but we received a message saying that Miguel Nicolelis doesn't have internet, so he's not able to make the talk. So we will follow the schedule and return at 2:40 with Tim Brown's talk. So apologize again, and we look forward to see you back then. Okay. We extend the break for the moment. Hi everyone. I'm pleased to welcome you all back to the second part of the conference. My name is Jacopo and I'll be hosting the next speaker. We apologize again for the inconvenience, but unfortunately Professor Nicolelis had technical problems. So having the conference online is great because it allows us to invite people from all over the world very easily. But this is an example of the negative aspects that we can unfortunately encounter by relying on machines. So moving forward, it's a pleasure for me to introduce the next speaker, Professor Tim Brown. This will be followed by a panel discussion hosted by my colleague Isabel. Let's get straight into it. So Dr. Brown received his PhD in philosophy from the University of Washington. He is now an assistant professor of bioethics and humanities in the University of Washington School of Medicine. His current work is on neuroethics, where he explores how neurotechnologies impact our experiences of agency. Today, he will present a talk entitled Sensory Feedback in Assistive Robotics, Embodiment, Agency, and Self-Trust. I'm pleased to welcome Dr. Brown to take the stage and start with the presentation.
Sure. Hello, everybody. It's an honor to be here. I was not aware of the technical difficulties that occurred with the previous speaker, so I'm glad I'm here now. Yes, this talk is going to be called Sensory Feedback in Assistive Robotics, Embodiment, Agency, and Self-Trust. So this talk is mostly going to be from a philosophical and a neuroethical perspective. So we're going to talk the ethics of neurotechnology. So let's jump in. So brain-computer interfaces, especially devices like prostheses and assistive robots, are presented as a means of transforming medical practice and interpersonal life. So on the left here, we have the well-known BrainGate device that is a collaboration between a lot of brain-computer interface research centers here in the United States. On the right, we have Neuralink. You're probably all familiar with Elon Musk's brainchild. I guess that's literally and figuratively. This sexy new device that's supposed to read and stimulate across 1,000 channels and connect to Bluetooth to a smart device and so on and so forth. I want to think about a specific technology, so I'm thinking of biomimetic feedback for prosthetics and assistive robotics that promise to give users feedback for improved control and feelings of embodiment and ownership over said devices, right? So this is the use of recording systems for brain-computer interfacing, but also applying stimulation to the sensory cortex to give a person a lifelike or biomimetic feedback. In the case of using a system like a prosthetic limb or an external assistive robot. With this kind of feedback, you can, or at least it is proposed that you'd have higher acuity in the way you use a brain-computer interface. So instead of having to go by visual cues in how you're controlling a brain-computer interface, be it in some BCI control task on a screen, or the actual movements of a robot that you're controlling with neural signals, you can go by direct feelings induced by a stimulation system. And this should be an improvement. Should make the experience more natural, right? But in this particular paper by Collins and colleagues, people receiving stimulation feedback during a BCI control task reported that the sensations elicited by electrical stimulation felt unnatural and unlike anything they had ever felt before. Nonetheless, they were better able to use a brain-computer interface with this feedback, but it was a weird feeling. So even if biomimetic feedback does improve control, how will users incorporate these systems into their everyday lives? This is my question. How will it affect their agency or sense of self? And chiefly, will users find a way to be themselves with or through these devices? Me and my colleagues, we, through NIH-funded research, arrived at a way of conceptualizing agency in the context of lots and lots of different kinds of brain-computer interfaces. So we came up with the idea of an agency map. And this is supposed to give us some idea of, or some really easy reference to refer to for the different parts of what we imagine agency to be affected, to be like when it's affected by brain-computer interfaces, or in the interaction between people and brain-computer interfaces of a number of different types. We generally depict here the kind of neuroprosthesis use that a lot of research groups are imagining their technologies will enable. But we also had in mind a whole host of different kinds of technologies. So not only brain-computer interface controlled robotic and external prosthetic limbs, but also things like P300 spellers, things like deep brain stimulators that also record for biomarkers of conditions, anything that records and stimulates the brain and may have an impact on agency. Here's what our picture of it is. And on this model, we imagine the agency has 4 different aspects. This is, of course, not an exhaustive picture of agency. We think that agency is a multidimensional and very complicated concept, where some people would limit the concept of agency to the idea that we form intentions, enact them, and live with the consequences. We think that process is involves many different resources and outcomes and techniques. And so in the upper left-hand corner, we have authenticity, where a key part of agency is to be your most authentic self, to act on behalf of yourself and stay true to yourself. On the upper right, we have privacy, where we have to negotiate the boundaries between ourselves and our related others such that they have access to information and resources, internal resources. On the lower left, we have trust, where the information given to and that we receive from neural technologies are they give us information, and we have to decide whether or not we trust them, or we give them commands and we have to decide whether or not we trust ourselves to give those commands, or for it to follow those commands, or for us to give adequate commands. And on the lower right, we have responsibility, which is the classic problem with neuroprosthetics. What happens when the system tries to decode my intentions and bring those intentions into action? And what if that process goes wrong? Who is to blame? And that's the classic problem. But we're focusing in on the trust aspect of this, right? So each step in this process of sensing, at least in the case of neuroprosthetics, each step in this process requires trust in this related agent, the prosthetic limb being something that I'm related to in a way where I'm trusting it to follow my commands, or I'm trusting it to give me reliable information about what it is I'm doing in the world. But each step in the process requires trust. The sensing platform has to trust what it's picking up, how it's being encoded, and I have to trust its sensory stimulation patterns. And it also requires that we figure out a way to trust ourselves. And so let's talk more about that, the figuring out how to trust ourselves part through a case. So let's consider the case of Rachel and her assistive robotic limb. So Rachel is a 35-year-old woman with a incomplete C5 spinal cord injury, with loss of most motor function in her arms and legs and patchy sensory loss below her neck. She is impaired, but she can still feel a little bit. She decides to enroll in a pilot brain-computer interface study, which will allow her to control a robotic limb mounted on a power wheelchair by using only her thoughts. This is motor intentions, imagined motor intentions in her motor cortex. Implanted electrodes record intentional neural activity, allowing her to control the robotic arm. And the output of the sensors on her arm are turned into sensory stimulation, allowing the device to feel more real as she controls it. And this, again, should give her better control over the device, giving her more accuracy in how she controls the device. But imagine the feedback from her limb, her robotic arm, is at odds with her other sensory feedback, her residual sensation. So she can feel a little bit. So now she's feeling from two limbs. She's feeling the sensations in two limbs, her artificial one and her natural one. What if Rachel uses her robotic arm to shake someone's hand and then they cry out in pain? But the sensory feedback from the robotic arm registers a gentle grasp. It should register a firm grasp, as if they're crushing someone's hand. Instead, it's just a gentle grasp. Should she trust her ability to use the robotic arm safely and interpret its feedback appropriately? Or her ability to detect an instance of pain caused to another? Maybe not. This is difficult. So there are a number of conceptual resources here that could help us. My longtime advisor and collaborator, Sarah Goering, here at the University of Washington in the Center for Neurotechnology, has a few insights here. She compares deep brain stimulation and other neurotechnologies to the interventions of a new boyfriend. I'll just read her words. We might compare my DBS to a controlling new boyfriend. As the new boyfriend interacts with the system that is me, he may even become part of me, given the regularity or the intensity of our interactions. My relationship with him is only one part of the wider me, but it's a troubling one. He changes me, perhaps for the worse. So she and I are imagining very, very deep and very complicated relationships between neurotechnology and its users. And those relationships can bring into question whether or not you can trust yourself with this device. Just like you have to wonder, do I trust myself with this new boyfriend? And I might need someone to tell me, oh, the boyfriend is ruining my life or making me into someone I'm not. So trust and self-trust are important features of agency. So Carolyn McLeod argues that the people that we trust have an enduring commitment to acting in a morally respectful way toward us. And we want their actions to accord with that commitment. Of course, robotic limbs are not moral agents in the way that we normally think of moral agents, like other people, everyone on this Zoom call, right? Where I can ask, why did you do that? And you can give me responses that make sense or don't. But Philip Nickel argues that we trust others when it's possible to recognize that their actions line up with our interests, and that we have warrant to believe that they can carry out those actions adequately. This definition is Philip Nickel's attempt to make this more generic. It doesn't have to be a moral, someone who is worthy of moral status. It's just, it could be an object that acts on our behalf, or is supposed to be designed with our best intentions in mind, right? So I think these two views stack up in an interesting way. And to be ourselves with neurotechnology, it's a lot like being ourselves with other people, right? So Hilda Lindemann gives us some help here. She argues that relating to others, that related others play an active role in constructing and maintaining our identities even. So who we are is in part determined by who we are around. Not only through negotiations, which are furious, like imagine when you're a kid, not imagine, but remember when you were a teenager and you were arguing over your own identity, trying to defend it from your parents or your grandparents or whoever it is, or your friend circle. It's a kind of theatrical performance. We hold one another in identities by performing those identities together. And in a way, that might be how it works for a prosthetic limb. Alyssa Bierria argues that others' recognitions of our intentions is crucial to our exercises of agency, a part of what she calls the social choreography of agency. And failures of this recognition can be dangerous or fatal. For Alyssa Bierria, she was thinking about racial injustices, being recognized as a full human or a well-intentioned human by the police. I realize this is, in the UK, the police service is probably not nearly as problematic as it is here in the United States. So this is the sort of thing that we're considering. But in the case of prosthetic limbs, these systems are decoding our intentions, encoding the sensory feedback, all with the goal of giving us the ability to move through space and accomplish certain tasks. It's all goal oriented. And so failures of recognition can be fatal. If Rachel were driving a car, if Rachel were holding a baby. And so it's important that our devices recognize us and our intentions. And then there's the direct question of how are we ourselves with assistive devices? Julia Watts-Belzer argues that wheelchairs are not just dead matter. People who use wheelchairs are not just dead matter that require movement through mechanical means. There's a way of reduction that happens when people use wheelchairs, especially manually operated ones, to where people are pushed forward without any consent or against their will. Those two handles on the back of the average mechanical wheelchair seem to give people the impression that they want to be pushed. But the wheelchair takes on the wheeler's movements in some moments and resists movement in others, and sometimes seems to have a character all its own, according to some wheelchair users. Belzer calls this an intricate partnership between the wheelchair user and the wheelchair. And they rely on them, act with them, know what to do when the wheelchair resists. This is a relationship. So In a paper I call Intricate Partnerships, I argue that our relationship with assistive devices is the relationship that we have with related agents, right? So just like people, we exercise agency in tandem with these devices. We rely on their recognition and participation in our goal-directed activity. And we confer animacy on objects that allow us to exercise agency through and with them. And we rely on their responses to us. And if we think of these assistive devices as agents, we can say that the social choreography of agency in Bieria's language relies on our relationship with them. So we're performing with them. So to close, in many ways, these devices are in this weird, uncanny space between being a part of us, being an extension of us, being related to us. And we'll need to think through each possibility to make sense of Rachel's dilemma and devise ways of tuning the system's design or providing guidance on how to prepare for these possibilities. Rachel needs help. The end goal then is to prevent the system from undermining her trust and self-trust. In the future, that will likely mean that we give her the kinds of help that that will support her in playing some role in tuning the system. Most of these systems are artificially intelligent and require a training step. What does that training step look like? What should be done? And what safeguards should be placed on those systems such that they don't go out of step with the user's intentions? And what safeguards are too much? What's a severe limitation on Rachel's freedom or Rachel's liberty? These are questions that we have to consider. But for now, that's it. That's my talk, and I look forward to your questions and comments.
Thank you very much, Dr. Brown, for your very interesting talk. We do have a few questions. So there is a question by Robin. You are welcome to unmute yourself if you prefer and do your question. Okay, yeah. Okay, Robin says that is interested in the possible applications for sufferers of various forms of dementia, especially the early onset sufferers, for example, mild cognitive impairment, and is asking if you see possibilities for active intelligent agents that could mitigate and or delay the cognitive deficit engendered by dementia, i.e. Can we possibly extend individual agency by artificial means in the twilight of life or in early onset cases?
This is really difficult. So the idea of doing any kind of stimulation, or in this case, it would likely be closed loop stimulation, reading for certain kinds of impairments and bypassing them through stimulation. In a population like people with dementia or Alzheimer's, it's a very difficult problem because on one hand, you have to convince them to get the device, and but also a lot of the people who receive dementia, or receive treatment for mild cognitive impairment or dementia or Alzheimer's, are not receiving adequate social care in the first place. At least here in the United States, right? So again, I have to give that disclaimer. I think people receive care elsewhere and it's more adequate. But in a lot of cases, people don't know how to deal with people with cognitive impairment or Alzheimer's or dementia. But that's certainly the goal behind a lot of the research. So neurostimulators for the sake of preventing dementia. But it's not clear what the efficacy of those systems are, and I think as with any technology that stimulates the brain, I think there's promise, But I'm not sure what the efficacy will be, because a lot of those studies are in process. They are in the works. So cross your fingers. But again, it's really hard to get consent for those projects. But and also, you know, the social supports are inadequate. Inadequate in especially intellectual supports, the intellectual frameworks that we use to talk about Alzheimer's and cognitive impairment are a little dated, and as a result, forms of ableism creep into the conversation, and that means that we don't treat people with cognitive impairment the way we ought to treat them. Hopefully that answers the question.
Okay, yes. There are a couple of more questions by Sam. So he's asking if you know if the neuroprosthesis devices that you mentioned are co-produced with the participant in question. If not, could this perhaps benefit the sense of trust and agency if they are part of the development?
I'll answer the second question first.
Okay.
Because it all depends on what you mean by co-produced. Yes, I do believe that some kind of co-production, some sort of deep participatory component in these projects could help people develop the kinds of trust that they want to develop, or that they need to develop to be able to use these devices competently, or that they need to develop if they want the device to be competent with them, right? So we're always flipping this on its head. It's not always on the user. It's also on the device and the device implementation. At some point, co-production is a kind of inevitability in this space, right? Because the devices are so new. In the case of the BrainGate trials, and I believe it's the BrainGate 2 trials, where they're working with wireless platforms now. Yeah, it's inevitable that the research participant comes in monthly, spends a whole day in the lab, while a group of graduate students figures out how to make the system work for that person with their deep and considerable feedback. And so, yes, I think so. But we need to make sure that that carries over into the clinical practice of issuing neuroprosthesis devices. We can't just say, here's a thing, go on and use it. That's definitely not how it's gonna be. But we may need to be even more hands-on than we are even in the cases of, say, more robust deep brain stimulators, right? So like, here's a class on how to use it. Here's counseling for the clinician, the neurologist, and the patient, that they both take together to figure out how to navigate the ins and outs of these devices. Yes.
Sure. Okay. Yeah, this surely helps. Okay, we have another question from Paolo. He's asking how far does this perspective around devices extend to, e.g., dialysis machines, glucose meters, insulin injections, or even non-medical smartphones, computers, Wikipedia? That's the question.
Yes. So when I say that there's an uncanny space between these devices being part of us, extensions of us, et cetera, I'm thinking of a lot of different literatures. I'm thinking of Andy Clark's Supersizing the Mind. It's a great book. Great work in somewhere between the philosophy of technology and the philosophy of mind. Considering the possibility that devices, not even the most high-tech devices, sometimes just the notebook for the cognitively impaired, can be extensions of us. I'm also thinking of Marshall McLuhan and, you know, this idea that the medium is the message. And these extensions of us, right, they have deep implications on what it means to be human. where, but I do want to express some kind of caution. You know, the feminist post-humanists rightly point out that not everybody is a cyborg. Some of us are just, you know, playing cyborg, or some of us are just on the outer cusp of being a cyborg. Some of us are going to be actual cyborgs who have devices and are mediated through technology. So I would caution us against saying, I'm a cyborg now, I have my iPhone. But definitely, I think that I think this perspective does extend to devices like, especially those devices listed: dialysis machine, glucose meters, insulin injections, cardio defibrillators, so ICDs, where people form relationships with them, and some of them are not productive ones. With implanted cardio defibrillators, for example, those can go off at any time and they feel like being shocked in the chest by a bolt of lightning. And some people carry around magnets to in an emergency disable them. And that's a very strange thing. If you want to read more about that, there's a book called Lightning Flowers by Catherine Standifer. That's amazing. But yeah, you, Paolo, you found me out. That's the whole next stage of my career, to extend these views into medical technologies more broadly.
Okay. Seems that more questions are coming. So there is one, yes, by Carla. Would you say that this same ethical issue also applies to prosthetics that are not linked to thoughts, i.e., there has to be an element of trust between all prosthetics devices and the user?
Absolutely. When I hear about people who are either amputees or people with spinal cord injuries who are using orthotics, exoskeletons, devices like those, people with intrepid attitudes about their spinal cord injury receive all kinds of devices from device manufacturers. So in the case of exoskeletons, there are literal skeletons in people's closets that they don't use, right? And so it's a matter of, and why don't they use them? And that's a matter of, you know, they're hard to don and doff, they're hard to use, they put pressure on certain areas of their body that make it more likely that they'll develop sores. Some devices feel like, I don't want to say death traps, but certainly torture devices. And so you certainly wouldn't trust a device like that, right? So, and even when these devices are not linked to your thoughts, we all have experiences like that, right? My family often would call a car that felt particularly unsafe a death trap. So I think this view definitely extends to devices that are not connected to our thoughts. They're connected. I mean, any device that we can form a relationship with. We might think of this as frivolous, but I'm inviting us to take this seriously. That these relationships do matter, and it's not just an aesthetic thing. But the aesthetic is not something that we should discount either, right? It's a moral aesthetic. A moral aesthetic consideration that we make of everything that we have, from our furniture in our house to the computers that we use, to the cars we drive, if we drive a car, to the friends we keep, right? So we're always evaluating things in terms of how it feels in our life to interact with these people and things. So don't underestimate that. Yeah.
Okay, thank you very much. This is very interesting. So there will be time to answer other questions during the panel discussion. And yes, that will be hosted by my colleague Isabel. Over to you, Belle.
Thanks, Tim, and thank you to all our three speakers. It's been a really wonderful session. And thank you to the audience for all the questions as well. So if you didn't have time to have your questions answered during the Q&A, now is a good time to ask it. We're going to have 30 minutes of panel discussion, and we really want this to be an interactive process. So please just raise your hand if you want to ask a question to any of our panelists, and I'll let you know when you can unmute yourself. But if you're not comfortable with unmuting yourself, you can always just ask the question in the chat and let us know, and I will read it out for you. So to start it off, I think we have a few questions already lined up. So, Matilda, would you want to ask a question? Oh, Carla first. You got your hands up. Sorry.
Hi, thanks. Really interesting talks. I had a question for David about kind of the interoception stuff. And I know that you mentioned people with panic disorder, and I wondered whether there's a possibility that people with panic disorder might be aware of their heartbeat, for example, but they might misattribute how fast it might be going, which initiates sort of a panic. So there's sort of a distinction between being good at being aware of your heartbeat and being unable to know actually how fast that's going, relatively speaking. And I also wondered whether, if you're good at having interoceptive awareness of your heartbeat, does that mean that you're good at knowing sort of other bodily signals as well? So is there a correlation between these things? Because I've seen cases where people with panic disorder are so immersed in their sort of maybe their heartbeat that they then forget about, you know, their hunger signals, etc. Maybe that's a hyper focus, and maybe if they step back, they would be able to do all these things very well. But yeah, I just wondered what your thoughts on those things might be.
Yeah. So, I mean, when I first presented the protocol for the phase adjustment task, David Clark at Oxford kicked my butt in that I hadn't accurately accounted for panic cases, and what would happen if we tried to train interoception in people who either had panic disorder or were undiagnosed, or could be triggered by interoceptive training in panic disorder. So then I had to look at that literature very closely, and one of the things that I found interesting about it was exactly what you're bringing up, which is that how to understand what the signification of a good or a bad signal means to somebody in panic is really difficult to do in real time. So obviously, I mean, it's really difficult to do, period, but to pretend that we could do it in an app that automatically assesses interoceptive signal is really quite a leap. I mean, the brute force approach to this is to exclude people who exhibit symptoms of panic disorder from all research to do with interoception altogether until we understand better. But yeah, your question points at something really quite murky about how we either assess interoceptive signal perception or, more importantly and more dangerously, train it. Yeah, but that doesn't really answer your question, right? Which is to say, if you have somebody whose perception of heartbeats is already nociceptive, I've just blanked on the opposite of anxiolytic. Can somebody help? What's the actual word for stress causing, anxiety causing?
Stressor.
Yeah, I mean, that'll do, right? Yeah, so if you perceive your heartbeat signal as a stressor, the subtlety of that perception is really quite interesting, right? Because is it too fast? Is it perceived as too fast? Is it perceived as too slow or too erratic? Is it perceived as too monotonic? What happens if you know that monotonic is bad? What happens if you know what atrial fibrillation is bad? That atrial fibrillation might be bad, and you know, all those things. So there's something that we cannot easily account for, which is the amount to which the user is playing into the knowledge that they already have about the signal versus how the signal appears to be a stressor, or in any way something that feels to them a dangerous thing. And I have no idea. I really don't know. I mean, what we're doing for now is to make sure that we account for the rise of panic in as a trigger, as part of the data pool that we gather. So galvanic skin response, or EDA in general, as well as rapid changes in heart rate and rapid changes in HRV. We then monitor those very, very differently and stop the training immediately. So the app, for example, at this point, stops the training and goes into a different screen where we ask ask the users questions about what just happened if we see that there's a sort of trigger event going on. But it's a really delicate protocol that I don't think we're going to be able to like try on patients anytime soon because quite rightly, people like David Clark are going to shut me down.
That's really interesting. Thank you.
Thank you.
Thank you. And I think Sam has a question next.
Oh, I might have to go to that.
Well done.
Sorry, we're all in the same room. It might not look like it. But feedback will happen if I ask from over there. Yeah, I had a question for Tim. And you showed this amazing graph of how you and others had conceptualized agency between 4 different kind of key areas. And I was just wondering if you could speak at all how the different areas might interact with each other, if you've considered that, and perhaps there's an interesting intersection between trust and privacy, especially with neuroprosthesis, especially considering the amount of capital behind these new devices that are coming from quite large corporations. I just wondered if that was a consideration in your research at all.
That's an excellent question. Oh, those are excellent questions. I think that, and he slides away. I love it. I think that both of those areas are very, very much prominent within our research. So the question of whether or not these 4 quadrants, these 4 aspects or dimensions of agency are interrelated. We think they're interrelated at every point. Well, maybe not every point, but many different points along the use of neurotechnologies, especially brain-computer interface controlled prosthetic limbs, right? So there's always a question of what access does a person have to me through my prosthetic device, and what my moral obligations are in protecting those boundaries and negotiating the access that other people have, right? So that's the way we've presented the privacy and security concerns. But how I negotiate the boundaries or allow other people to negotiate my boundaries is a matter of trust. Whether or not I trust myself to make those decisions for who I allow to even interact with me in certain ways. Who do I trust myself to interact with in certain ways? And what information about myself I give up, though I don't want to lean into that kind of account. We're trying to go beyond the data governance account of privacy that most people use. We think that privacy is a relationship, like a lot of different things here that determine our agency. But also there's a matter of representation, right? So does my device act in a way that is legitimately me, right? And if it doesn't act in a way that's legitimately me, that I find authentic to myself, do I have a responsibility over it, or a responsibility for it? Can I truly own the actions that come out of a device that's really not acting on my behalf? This wraps up all 4 dimensions of agency. If my device acts in a way that I don't think represents my personality, my identity, my intentions, and my goals for action, I might not think of it as authentically me. I might not think that I should be held responsible for those actions. I might not trust myself to use that device. I might turn it off. And I might not trust the other people around me at that time. They might misinterpret me. And again, like I said at the beginning when I showed that chart, it's it's not clear that these are exhaustive categories for different considerations of agency or dimensions of agency. So in all likelihood, other things are present. But yeah, so definitely, this is something that we're thinking of. As for your second question about how sociopolitically oriented or positioned these devices are, or how open to the intervention of multinational corporations this renders us, or these technologies render us, yes, I am completely worried about that. And I think it's safe to say in this space, I find that I find that in the United States, there's a relatively shallow understanding of the security and the privacy threats that multinational corporations have. And I know that we're just waking up to the problems with Facebook and the problems with Instagram. But, you know, Facebook Reality Labs is always working on technologies, always buying up companies that have really interesting technologies that are in this space. They do overlap. In full disclosure, I've given talks to Facebook about the moral implications of the devices that they're creating. But the problems extend far beyond Facebook. I mentioned Neuralink in the beginning, where Elon Musk is imagining, you know, a transhumanist future where he can upload his consciousness into the cloud. But then again, right, if we think about what cloud computing is, it's, you know, controlled by a few multinational corporations like Amazon Web Services and Google and Azure, which is a Microsoft product. And so if we're talking about the frontier of neural technology and neural data, our neural data is going somewhere and serving some corporate interest. And I think that really does change the landscape of our bodies if we have devices that are using those frameworks on our persons. So it's not just the device in my pocket, it's my arm. It's my arm, and it has some link with whatever corporation is hosting the server and whatever global initiative is managing the data or sharing the data for the sake of, they say, innovation, which I do believe that data sharing is key for innovation, but there have to be limits, there have to be guidelines, and there has to be oversight.
Emanuela, so sorry.
Yeah, thank you, Tim. I kind of got wondering if, with Emanuela, of how your work kind of, do you consider some of these ethical issues as well, especially with your aromatherapy and things like that? What if it becomes triggering instead of more therapeutic? Have you taken those things into considerations?
Absolutely, like more implication. And unfortunately, smell, I mean, I would not consider aromatherapy one of my research topic, but what has been done with smell so far, it was used for marketing communication. It's like a misleading information in stores, for instance, where there is like smell of bread and there is not a bakery there, just to trigger impulse buying. And luckily now is illegal, so they need to advertise and make aware the consumer they are using these kind of marketing strategies. But taken to the extreme, and I will comment on what we were discussing, yes, everything is now kind of cloud-based, data-driven, and we have control as much as we can. We protect data with how the structure and infrastructure, both university size and using policies, but still there is kind of a kind of unique control over the data, and it's very difficult to protect personal data. And we try to do our best, because with this kind of longitudinal study with patient, we need to collect constant data, and even we would like to merge other kind of information about healthcare system, going in direction of the digital healthcare data, the centralized system, which is coming with a big plus of allowing good prediction models, integrating different factors and monitoring the patient, but in the same time it's difficult understand how to protect the single individual, and still a lot of users are afraid of sharing their data, and they are questioning why, which is a good perspective, because I think they should be aware how important is the data in this very moment. And I've been also working for a big corporate, VR corporate US, and I know the kind of work they do, and I know the border between ethics and non-ethics. But this is, I think, is a big question, is also involving us as a researcher all the time, if we deal with technology or not, as well as like a thin boundaries for us to keep our ethical standard or refer it as much as we can to overall policies to protect then individuals or what we are doing.
Thank you, Emanuela. And we've got a question from Robin.
Yeah, thank you. It's actually two questions. I've been listening in as a non-specialist, previously an engineer in construction, and now working for an Alzheimer's charity. And I really warmed to Timothy's talk because I could see some real world applications there. And the first part of the question is, what do you think could be translated into remedies or alleviation measures for dementia? And then the second question is a more general question for the board, because when I started reading in this area seriously, I came across Principles of Neural Design by Sterling and Laughlin at MIT. And I'd like to know where that sits in the current research landscape, because it seems to me that these principles of neural design could be reverse engineered to understand something about how dementia starts, because we know that it's decades in the making. We don't fully understand all the triggers yet.
Great questions. So you were asking about dementia in particular. I am not an expert on dementia, even though it's a hobby horse of mine that I hope to publish papers on at some point in the future. But there are some considerations that I think that we should get out of the way. So when it comes to people with dementia, people with Alzheimer's, and other memory impairments, cognitive impairments that affect us in later life, one of the big problems is that people really want to question a person's knowledge, right? The goal is to get them to where they were, to keep them from going where we think they're going to go. We want to prevent their cognitive decline. And bound up in that is a moral obligation of a person with dementia's family. I mean, or the person with dementia has to their family with regard to their knowledge, with regard to their memory, where family members will say things like, if you don't remember me, then what good are you? Or if you don't remember me, then our relationship can't go anywhere, because I want my mother, I want my father, I want my aunt. So the ability to play these roles with other people relies on memory, relies on cognitive function in certain ways, unless a person's not used to that person having certain kinds of cognitive functions. If a person had a memory disorder the whole time, they would interact with that person differently. And so what kinds of interventions should we be making on the relationships between people with dementia and people and their loved ones who don't have it? It's not necessarily, hey, let's give this person a device or a drug or something like that to restore their memories. I would caution us against this gung-ho attitude. I would say that we need to think seriously about how to support people in their relationships through social work. And that social work can involve neural technology if it gets to a point where a person really goes, yeah, I don't want to end up that way. But there are some people who are just fine ending up that way. Yeah, my cat is being a real jerk. She's a sweetie. Her name's Biscotti, by the way. And so, yes. And so I think it's a real difficulty. But your second question, I'll let someone else take on first, and I'll jump in after them.
Robin, would you maybe want to repeat the question? The second
Yeah,
question.
the second question was really about a very engineering-like approach to neural mechanisms, which was Peter Sterling and Simon Laughlin at MIT, who outlined a set of organizing principles to explain the whys of neural design that allow the brain to compute efficiently. And I was just wondering how we could use this possibly, because this struck me as a guy in construction, as a mechanism to understand how it works in reverse. How does a stable brain fall into mild impairment and then severe impairment through the various processes of Alzheimer's is the most commonly known, but there are many different forms of dementia.
I mean, I'm not an expert either in dementia, so what I can tell you is from the perspective of perceptual decline of what I've been investigating related to olfactory perception that can occur like 10 years in advance of cognitive impairments, which is a very long time. I think the answer, unfortunately, is not so straightforward. I don't think we have a model to understand how the brain works in the computational level. And I do believe that in these kind of degenerative diseases, Alzheimer or other type of dementia, there are genetic factors also occurring. I think there is a lot of research going on, but I don't think there is a definitive answer to say, okay, those are the crucial factors. And what I do believe is kind of prevention as such of monitoring and understanding when there are some triggers they can start to induce attention of patient to reporting those symptoms and get some deeper like analysis and checks, because the main problem in this kind of patient is the fact that maybe they seek for help when it's too late. So the dementia is already in a stage in which has been started many years before, but they didn't pay attention to little details or kind of memory lack and so on, which I think it's normal also to avoid to think about that. And I think this kind of big research agenda of making a multi-factors of components that can impact, and we can monitor to understand how a degenerative disease can kick in and when, and which are the indexes they can be from biofeedback or like even just changing in some level of hormones in the organism or perceptual decay like olfactory decay and so on. Is a kind of it's a very complex system, and I don't think we have an answer, but again, I'm not an expert in the area. I hope I just wrap up all the possibilities around that, but I think we are far away to have like just a machine system with different elements, and then we can say, okay, yeah, we compute like that.
Well, thank you, Emanuela, and I do appreciate your answer, and I recognize some parts of it, because when I started working and I was researching in this area, I tried to find a textbook on the 5 senses. And you know, I can't find one integrated textbook on the 5 senses. I don't know if anybody can suggest one, but the last time anyone attempted one was like 50 years ago.
Yeah, because I think there are senses that are easier to be studied, and from the receptor perspective and even the brain areas involved, and you can do easy like psychophysics studies, and you know exactly the threshold perception, which is more or less kind of cross individuals. So you can have a benchmark, but some senses as can be taste or smell is much more complex. So I think this is the challenge we are facing. So we don't fully understand how to even measure correctly some senses. So I think this is the reason why there is not such a handbook of say, yeah, please.
I'm so sorry, I didn't mean to interrupt.
No, please, David.
Oh, I was just saying that if you're looking at it from an overall perspective of the senses, Chris Chandler's psychobiology textbook on psychobiology, which is, I guess, master's level thing, is a really good book. There's 3 chapters on the senses that breaks it down from a structural perspective and then from an analytical perspective. I'll put it on the chat.
Well, thank you. Rhiannon, would you like to ask your question?
Hey, yes, I can, but I think Marco was first. He wanted to ask his question first. But if not, I can ask away. Okay, cool. So thanks for all the talks, guys. It's really interesting. Wait, let me put my camera on because I am here, I'm a real person. So hey, oh no, I've just lost my question. I did write it down. I was kind of really thinking of someone from outside this area, how your kind of areas may come together. And one thing that I kind of thought of was about interoceptive awareness, and specifically how olfaction could be used to help people with their own interoceptive awareness, or getting people into states where they might be more receptive to be able to receive these signals or at least notice them. So yeah, discuss.
Thank you, Rihanna. Nice to see you. I think this is a very good question again, and absolutely, yes, like self-perception of what you are smelling and what the smell is recalling you can help even what this kind of self-regulation of like, okay, you are an anxious person and you know you can use some type of smell just to relax. Like I'm completely addicted to smelling something constantly, so I'm not the right example, but definitely there can be a big kind of research application in that area, and it can cross kind of over all our talks today, and mainly with David, because I see like all the stressors. It can be also a stressor, by the way. It's not always positive, it can be extremely negative, can activate the trigeminal system, can be also a reaction of pain. So I think using the sense of smell in the direction of kind of body perception in this kind of regulating of self activity is also possible. But I leave David to comment further.
No, I think that's absolutely right. And there's interesting that olfaction is so active in the idea of reminiscence, right? Because it bypasses the thalamus, so it doesn't really, it's like a direct highway to some kind of reminiscence, and it's not my field, but definitely I agree with Emanuela in that there is a really good relationship, a really potentially amazing relationship between olfactory stimuli and the exploration of fear and panic in interoceptive awareness, particularly if we look at the idea of how those pathways work, right? If you just look at it from the amygdala's point of view, then fear alone would give us a reaction that we could see in changes in interoceptive awareness, and HIV changes would reflect that. But HIV changes aren't very fast, right? I mean, we need at least a few seconds of data. And I wonder, even from the perspective of designing therapeutics that could involve the two, how to involve design that involves the limbic system and the emotional impact of odors would be, I think, an amazingly interesting research. And there is people out there who've done VR research in olfactory stuff, but I don't think for sure, and Timothy was just nodding his head, and I'm sure he knows a bunch, right, of those, but I don't particularly. But Rhiannon's question is interesting in that in a digital domain, we don't do things like olfactory, because like, it's like, this is an app. I mean, you know, phones don't do that just yet anyway, like create olfactory environments around you or whatever. But I think when we translate this to environments where that can happen, it'll be really super interesting to look at for sure.
Yeah, and I just want to connect this because I think there was a question in the chat when I was speaking and I didn't follow and I didn't answer. Someone was asking, is there any model to predict these emotional reactions triggered by smell? And it is a model of like emotion. Do we have a model to understand and predict or anticipate emotion? I think amygdala as like the limbic system and so on is all what is triggered and is activated. And what I use usually is always like fight or flight, like flight or fight is like Darwin example, like I approach something or avoid something. And the simplification of arousal and balance is what is the best. And you can have like the mirror in easy, like physiological biosignal has heart rate increase, skin conductance increase. And then it's a bit more complex to understand which type of emotion is it? Is a positive emotion without then having other contextual factor or self-repair question, or even just like using a self-assessment mannequin that is just identifying the polarity. But it's very in line with what David was saying, like we know fear is going through the amygdala reaction, and we know exactly what we can do with smell because it's triggering the same kind of system without conscious filtering. And luckily in the future, yes, we will have also a system to deliver smell digitally, and we will start to implement. And I think what we are lucky now in collecting data that are so kind of valid and cross-cultural, because there will be also a main differences on how we react to different types of smells as well.
Isn't that interesting, the cultural differences to reactions to smell? Because I mean, that plays exactly to what Timothy is trying to, well, some of what Timothy is doing, right? In what I can see in his response to Ilmanen, because if you think about trust in sensory feedback, when those sensory feedbacks can contain cultural modalities that aren't necessarily relatable to your own, you know, the smell of lavender to somebody who grows up in Luberon might be really comforting, but it might not mean anything at all to somebody growing up in Azerbaijan.
Absolutely. I mean, I've been doing testing with people like mainly in UK that are coming from everywhere. And I was using like lavender smell to test relaxation combined with some visual and audio stimuli from databases. Like everyone say relaxation, people, they were having panic attack, say, oh, what the hell is this smell? I never smelled it before. And it was completely having a different association. I mean, there are some basic chemicals that influence directly like the neural sensor system. So it can go in the relaxation family of chemicals. But you need then to stimulate sub-threshold. Therefore, you don't have the cognitive association of what does it mean, this smell. So you just have the influence without being aware of what is it. But definitely, like cultural differences in smell perception is so crucial. It's really an important factor.
And just to jump in as a humanist, primarily a humanist, a philosopher by training, and in this aesthetician also by training, there is a deep problem within philosophical aesthetics where we prioritize one art form over the other, and we conduct a kind of paragone, right? So we try to figure out if frescoes are better than paintings, are better than sculptures, or whatever it is that's on the table. And implicit in that paragone, or very explicit in that paragone, is the prioritization of different senses over one another, culturally speaking, where we underestimate olfaction and its import in our everyday lives. We make specious arguments about whether or not we would rather give up one sense over the other. Of course, we wouldn't want to give up our visual sense. We would much rather give up our olfactory sense to keep our visual sense. And these are specious arguments because they sort of trade in a kind of ableism, a ranking of disabilities, where normal functioning is the default. But in artistic practice, this sort of turns into a kind of prioritization of visual culture over oral culture over olfactory culture. And so the deeper exploration of olfaction is something that we're all familiar with. We all have those cultural associations of, I mean, I think one of the more universal ones is the smell of baking bread. And so, yeah, lavender, that the lavender case, I'm not sure what my response is, what my amygdala would do in the case of lavender. I do love lavender, but here in the US, we have dreadful shops called Bath and Body Works that try to kill you with lavender every spring season. But certainly that would trigger my fear response. I gotta go. But certainly, this is an underexplored area, and I think it's underexplored systemically in the humanities, and having the technological means to explore it would be powerful. And so I really think that this is amazing work.
Do you think that it's possible that the reliance on visual data points of reference over any other has caused a sort of interoceptive divide, like a sort of perceptual divide between who we used to be before visual culture was there so pervasively and now? Like, do we feel that's because of the prevalence of visual culture?
I'm not sure, but I wonder how far back visual culture goes. And I have every reason to believe that visual culture has always been the dominant form of culture.
Sure.
And probably at our great cultural loss. But then again, right? How do you pass down smell? How do you pass down taste?
I think I will answer yes, because there are many studies in sociology, but like they're analyzing different tribes isolated, and they have like completely taxonomy vocabulary to express colors that are not like digital colors as we are exposed as Western countries, as well of like smell. Our vocabulary of smell is a cross-modal vocabulary coming from taste sometimes, and also visual. Yes. And we don't have a vocabulary to express well what we are perceiving, while it's well established with vision. We can also associate, oh, this color is bright. Oh, sorry, this smell is bright. Why there are some tribes, interestingly, they have like a completely variety of different like terms just to define, I don't know, like some kind of growing of the vegetation, how they're in different season, they have different smell, something that we really don't have. So I will say we are a bit like Western biased by visual because we are bombarded by visual information, and it really depends of your cultural background. And society-wise, there are some like even like using of incense or other type of smell that are typical of religion cultures, but then is also part of what we are. So it's really, I think, yeah, yes and no. It depends of where you are in the world, but I will say like as a Western, yes, probably visual kind of overload everything so far.
Can I jump in actually and agree with Emanuela that visual did override all, but music therapy is proving to be a very fertile area in dementia studies, that people, identifying with the music that they learnt when they were young, and also the fact that our brains are complex adaptive systems. So we learn to, adapt to Facebook and all its stupid algorithms, and we've become highly developed visually, and perhaps to the detriment of some of the other senses.
Yeah, I mean, I think it also translates to sonic culture. If you look at the research that Ted Levin did at Dartmouth in the Mongolian deserts, there's a direct equivalent to what Emanuela was saying about cultures where the gustatory vocabulary is much wider than our own. Over in the deserts of Mongolia, there are like 30 different words for sound of a loud kind. not just its quality and its timbre, but also its significance and distance, because the visual culture around a desert is limited, in the same way as songlines in Australia are actually maps, and children learn to sing them in terms of the features of the song and the length of the song to walk somewhere, because the visual cues are simply not there in enough number to constitute a geographical map to use as topographical cues. I mean, I think we've largely lost all of that in sort of the loss of a connection to the body that we lost when we lost paganism and shamanism in many ways, right? The connection to people who listened a lot and who tasted a lot and touched a lot, as opposed to just saw internal vision as opposed to external vision, perhaps.
Can I just say that it is a privilege to be on a panel with folks who get it? Thank you.
Thank you, everyone. I'm aware we're running a little bit out of time, so I just want to give Marco a chance to ask his question before we go for a break.
Thank you. I hope it won't take too much time, but I wanted to ask David and the rest in general, like what was the basis of the success of your digital device intervention? Because the effect size seemed pretty good, right? 0.6, 0.8 for depression, anxiety. And I would have loved for you to go more into detail into the mechanisms by which people first lose their relation with their body and interoceptive capabilities, and in turn how it can be regained in an adaptive manner. And maybe also to connect that theme to the rest of the panel, because the title of this conference, Consciousness and Perception, what I'm hearing in terms of the overarching theme is basically how our sensorium grounds us and relates us to the ongoings of the world as such. And because there was a question before about the impairment of interoception, but for me, what it sounds like, what is more important, and why I'm excited to hear you guys talk, is the protective factors against impairment. And I think that should be the bigger question. And that's why I'm particularly interested in David's work, because it seems more well suited to not just be intervention for existing problems, but also a means to kind of, in a widespread, scalable manner, provide a protective factor for humanity. And that's why I mentioned in the chat phenomenological ergonomics. For those who are unfamiliar, ergonomics basically just recognizing the human factors in designing things or the world. And I think that is exactly the thing that has been lacking. We've had the capability to design a digital world or technical, or I would say abstract world around us, without the knowledge to ask the question, when is it well designed for phenomenology? So yeah, I'm not sure where I'm going with this, but I would just in general, first the specific question for David, and then would love to hear your thoughts on how your work could play a role in maybe contrasting the insidious mechanisms of dehumanization in modern society. Thank you.
You don't ask small questions, do you?
No, sorry. I tried to keep it small, but your panel got so interesting, I had to ask a bigger question.
We're going to need more time, but well, okay, so just to be really, really quick. First of all, don't ever believe effect sizes on digital therapeutics that are app-based without first considering that most of it is placebo. Did I actually separate the placebo? No, neither do Janssen Pharmaceutics when they do ketamine treatments for schizophrenia, right? Because it's inseparable. Like, I urge you to go look at a company called Biogen and their collaboration with ketamine therapeutics right now. Their board papers are available because they're a public company. Go look at their slides, right? And see the placebo curve versus ketamine treatment for schizophrenia. They parallel each other at every single stage, right? So when they give you their effect size, it's like, yeah, ketamine works. It's like, yeah, so does placebo, right? Mm-hmm. So, you know, when I published those studies, I also had a board of investors and I also had a board of advisors, none of whom encouraged me to track placebo at the same time. So this is where I get to confess that I don't believe those effect sizes are real, that actually when you put the principles of something like phenomenological ergonomics, you should also track not only placebo, but the effect that placebo has on cardiovascular resilience versus the actual intervention. Mm-hmm. Right? Did I see that? No. So, you know, am I regretting it now? Absolutely. And it's kind of like starting from scratch, because you think, okay, if we have an interoceptive measure that could, together with cardioceptive, cardioceptive measurement, but together with heart rate variability and the rest of the biometrics that we capture, give us a real sense of just how separate we are from placebo, just how far, then I would believe digital interventions. Until then, anyone's, including my own, are essentially just playing on placebo's power on top of interventive pathways that we already know work, like cognitive behavioral therapy, at least for some people. But to your second question, which—
Thank you, by the way, for being so transparent about that.
Sorry, yeah, no, it's super important that we're transparent about that, because every single digital therapeutic manufacturer out there, and that includes Headspace and Calm and Unmind and everybody else, is just publishing these studies, by the dozen in JMIR and places like that, without actually tracking what it means to design with something like the phenomenology of perception in mind as it relates to actual placebo. No one does it, and that includes me. So, but your second question is enormous. So I'm just going to say a couple of really quick things, and then hopefully Timothy and Emanuela will say something more interesting than I can. But from my perspective, this idea of phenomenological ergonomics, of the idea of basing the principles of any the digital intervention or digital therapeutic and its design on what you can see from a phenomenological standpoint is enormously important. And there are two things that I think could be done about it. One is that when you track what it is that you're designing for, like the outcome that you're designing for, and that outcome is just a reduction in, say, PHQ-9 scores or GAD-7 scores or something as straightforward as that, you should also design for what it is that you're accounting for when you use a measure like that, like GAD-7 or PHQ-9. And that's not possible to do unless you have real-time data. So I think if you're going to bring up something like phenomenological ideas behind ergonomics, the ergonomic design of the things that you design should take already into account that you're comparing against measures that never understood that in the first place, that never accounted for it in the first place. So I designed something called the breathing stone, which you can look up on the web. I'm not going to go on about it now, but it was a thing that looked like a pebble, like a large river pebble. It had ECG plates on it. It learned how to teach you a breathing exercise, a parasympathetic nervous system activation exercise, when you grabbed it. So when you grabbed it, it understood that, and then a very small operating system learned your HRV rhythm and taught it back to you in color and sound. It was a very small prototype, but it followed exactly the ideas that you're talking about. And then both investors and funders basically said, we don't know what to do about that. We've never seen anything like it. It's kind of like unfundable. And they're right, it's unfundable because there is no practice behind it. No one is thinking about these ideas in terms of the fusion between design-based principles, phenomenology itself, and the ergonomics. Never mind what people like Timothy do, which is understanding the reaction from the user. Okay, that's me, sorry.
Yeah, thank you everyone. I'm afraid time is up, but this has been a really, really interesting panel discussion. Thank you so much for taking part, and thank you, Tim, as well. I know there's a big time difference, so it's probably really early for you, but we appreciate.
Not anymore. It's okay now.
Yeah, so thank you to all three of you. This has been amazing, and we'll now have a short break, and we'll be back at 4:10 for the PhD presentations. And as everyone knows, it has been a slightly hard time for PhD students to get data in with COVID, so it'd be really nice for everyone to stick around so we can support them and watch their amazing talks, because they've got some really interesting works to show us. So thank you everyone, and we'll be back in 10.
Welcome back, everybody. We're about to go into some PhD student presentations. We've got a lineup of 4 students talking. So thank you, everyone, for staying on for these. We think it's really important to give students a spotlight, especially after the hard times that they've definitely been through, and we've definitely been through this the COVID pandemic. So the first speaker that we're going to be asking to come up is Itay Yaron from Tel Aviv University in Israel. And Itay's talk is on the consciousness theory studies, or contrast database, analyzing and comparing empirical studies of consciousness theories. So if you're there, Itay, go ahead and...
Hello, everyone. Let me just share my screen. Okay. You see my screen?
Yeah, that's brilliant.
Great. So thank you all for having me, and I'll present to you the contrast database as it was presented, providing an overview of the field of empirical consciousness studies according to its 4 leading theories. Across the years, different theories have tried to explain how our brain gives rise to subjective experience, yet these theories had thus far failed to converge into a common framework, with new theories continue to emerge without all the theories being eliminated and no consensus is reached. We asked if the current state of the field could be explained by the way that these theories were studied, focusing on the 4 leading theories of consciousness: global neuronal workspace, higher-order theories, recurrent processing theory, and integrated information theory. I do not have time to compare them all here, but I would be glad to do so later in the Q&A if you'd like. Yet importantly, these theories differ in their predictions and assumptions regarding consciousness. In order to examine how these theories were studied, we used 2 search strategies. The first one included picking 3 key papers for each of these theories and collecting all of the papers that cited these key papers. And our second search strategy was to collect all of the papers that used the name of these theories in their title, abstract, or keywords, excluding all of the papers that did not focus on consciousness and papers that did not interpret their findings according to at least one of these 4 theories. And this process yielded overall 365 papers, reporting 412 different experiments. Each was manually classified according to different parameters of interest, and I will discuss about some of them in this presentation. We collected this large database and we analyzed it, asking 4 main questions. The first one was if the theories are even put to the test, trying to understand why theories are not being eliminated in our field. We found a very strong tendency to support the theories rather than challenge them, and we connected this finding with another observation that this confirmatory bias was more prevalent in experiments post-hoc interpreting their findings compared to experiments being a priori designed to test theory predictions. And importantly, only a third of the experiments in our database were a priori designed to test theory predictions, and only 7% of them compare the predictions of more than one theory against another. Our second question was whether the field is as fractionated as it is commonly claimed, or are the theories in fact interact with each other? And in order to answer this question, we looked at the cumulative number of papers mentioning, supporting, or challenging each of these theories across the years. And we've noticed a very similar trend according to which the theory seems to accumulate supportive evidence throughout the years, so that the support of one theory doesn't seem to affect the level of support of other theories, with none of the theories showing signs of plateauing at any stage. Our next goal was to provide a bird's eye view of the field in terms of the main findings and trends. And this is especially relevant for our field since most of the reviews that are currently written are written from the standpoint of individual theories and are resulting in conflicting pictures. Yet it's still important to note that this is not a meta-analysis, as we did not try to assess the reliability of the findings I will describe shortly. So it's just a descriptive picture of the findings across theories. So quite strikingly, when combining all of the fMRI findings in our database, here colored according to the supported theory in each of the experiments, we've noticed a very heterogeneous pattern. As you can see here, almost the entire brain lights up. And we found it either when we conducted the analysis on the entire database or when we limited our analysis only to experiments focusing on content consciousness. Perhaps even more striking is the observation that when we split our database according to the supported theory, we found very good correspondence between the patterns we observed and the predictions of the theories themselves. And we found it for different theories. For example, when we limited our database to experiments supporting global neuronal workspace, we found this workspace. But when we conducted this analysis on other theories, we found other patterns that are in good correspondence with the predictions of these theories, perhaps except for higher order theories for which we just didn't have enough data. A very similar trend was found when we analyzed the findings in the temporal domain. Here, this figure aggregates findings from experiments using EEG, MEG, and intracranial recordings, with color indicating the reported component in each of these experiments, again, showing a very variable picture. And the picture again changes when we split the database according to the supported theory, with experiments supporting recurrent processing theory showing earlier timings compared to experiments supporting global neuronal workspace, again aligned with each theory's predictions. Yet still, you can see even within each figure here, there is quite a lot of variability. Finally, we asked if the diverse means to study consciousness interact with and possibly affect theory support. And specifically here, we asked if we can predict solely based on methodological choices of researchers, not even knowing what the findings of these experiments are, which theories will be supported. We used a random forest classifier and the leave one out strategy, trying to predict theory support based on the extracted methodological parameters of the different experiments in the database. And as you can see, our classifier was way above chance, which is indicated here by the blue dotted lines on each bar. So according to our analysis, yes, the methods that we use in our field are predictive of our final interpretations regarding the theories, but which are the parameters that drive this classification? So we found several such factors. For example, integrated experiments focusing on supporting integrated information theory were more frequently focusing on state consciousness rather than content consciousness, and used no report paradigms compared to report paradigms, but note that this pattern is correlated with the previous finding regarding content and state consciousness. We also found that subjective measures were more frequently used in experiments supporting integrated information theory, and that experiments supporting recurrent processing theory were less reliant on connectivity analysis compared to the other theories here, for which this kind of analysis was way more prevalent. So to conclude, we found that most of the papers in our field tend to support the theories rather than challenge them, and we connected this observation with the low number of experiments being a priori designed to test theory predictions. We also found that the methods that we use to study consciousness are predictive of the interpretations regarding the theories, hinting at different biases in the way these theories were studied. In order to enable you all to analyze and access this database yourselves, we created an open website. Here I created 2 video clips describing how we use different interactive plotting tools that we included in this website, and I invite you all to visit it. You can also export the list of papers populating each of these graphs. And finally, I want to thank first the organizer of this conference for this great conference and for inviting me. And thanks to all collaborators, to Lucia Meloni, Michael Pitts, and of course to Riyad Mudrik, which you've already heard, and to the High Level Cognition Lab in Tel Aviv University. Thank you.
Great, thank you so much, Itay. Yeah, as people are saying in the chat, terrific work, and it seems like such a valuable resource for scientists in this field. We have time for one question, I think, and there are a couple comments from Sina and Tess, and they're kind of linked. And it's, do you think that there is so little publications that challenge theories because negative results are often not published?
That's a very interesting question, and I'm glad you've asked that. We actually are trying to address that currently, thinking about this option. And what we found is that in other fields of research, especially within the field, within psychology, this reflects a general trend in the field and does not necessarily reflect only the field of consciousness. So I would say that, yes, there is a bias that is more general in science. Perhaps less so in experiments in the in physics or in other fields of research, I can give you in the chat a specific paper discussing specifically about that, about the supportive bias that is general across fields. But yes, I think that it is general.
Great, thank you so much. People are asking for the links in the chat, so if you want to drop them in there,
Sure.
and we're going to move on to the next speaker.
I'll stop my share.
So our next speaker is Kristjan Kaup, and they are going to be presenting on their title, which is Insights into Virtual Reality. I'm just going to give Kristjan a little second here to...
Yeah, thank you. Thanks a lot. So greetings. Thanks to everybody who is behind organizing the event, and thanks to all the speakers before me. It's been really a great and insightful event. So I hope I can get this out of the way. I hope you can see my screen. And
yeah, that's great.
Yeah, great. So anyways, I'm a first-year PhD student in the University of Tartu, where I work in the computational neuroscience lab with Jan Aro and Madis Wasser, where for the past half a year or so, we've been working on creating a virtual reality experience to elicit mystical type experiences, insight, and also therapeutic benefits. And for just, go through a little bit of background first. Last 15 years has really seen a massive rise into research into psychedelics, with these type of headlines being really common in very popular media outlets, and also the number of clinical studies that have been released regarding psychedelics has been rising really quickly in the past 15 years, and also the amount of publications regarding psychedelics has been rising very fast in the 15 years. And one of the main reasons behind this seems to be that psychedelics seem to be very helpful in treating different psychological issues such as depression, anxiety, different types of substance abuse such as opioid abuse, cannabis abuse, tobacco addiction, and alcoholism, as well as OCD and end-of-life distress. And what seems to be the case is that the therapeutic benefits of psychedelics seem to be mediated by two factors, which are mystical type experiences and also insight. And very intriguing results from David Glowacki and his team in the University of Bristol have also shown that virtual reality can actually induce mystical experiences that are comparable to moderate doses of psychedelics. And based on this, we have also set up to create a similar virtual reality experience. What our experience differs from the previous Glowacki's design by the fact that while they implement the concepts of these states, we have really tried to imitate the phenomenology of these states on a more straightforward way. And we have based this on the phenomenology of psychedelic and mystical experiences, as well as deep meditative states and generally awe-inducing views, such as seeing beautiful things in nature or seeing the Earth from outer space. And more specifically, one of the central concepts that we've implemented, I will not go through all of them, I will just discuss a couple. One, for example, is audiovisual synesthesia, where we really try to combine the auditory and the visual signals so that they sort of move together in a way, creating a sense of synesthesia, as well as another thing that's really important is trying to mimic or create a sense of ego dissolution and try to do it through this audiovisual medium. And this is really could be important because as these models that contain the sense of self are broken down, then this might help people to come see things from new perspectives or come to new ideas. And also we have tried to really implement alterations in the experience of time and space, where we play around with how fast and how slow the experience goes, and really play around with this and change it in waves sort of. And and also space, making it bigger and smaller relatively. And I have a couple of small little video clips. So for example, in the beginning of the experience, the person is sort of sees the real world through cameras that are on the virtual reality goggles. And here you can see an effect of trails, which is a very common occurrence under psychedelics, where sort of everything that moves leaves like an after effect behind it. And then at some point we move into more abstract. I hope it doesn't lag. It might be a bit laggy for you. I'm real sorry for that. But at some point we move into more abstract, kaleidoscopic, geometric pattern type of things, which are also central to psychedelic experiences, as well as into more like nature views where you hear a person is flying in the clouds and sees like a mountain range that has, color shifting effects, which is also part of the psychedelic phenomenology. And we have done some really preliminary experiments with this, which the results of which were quite surprising for us, where we found that 2 of the 9 participants that we had actually a complete mystical experience as measured by the mystical experience questionnaire, and multiple participants, at least subjectively, reported that they felt, a change in how time moved, that they didn't really, the experience might have been, one person said the experience might have been 2 minutes or 1.5 hours, while really it was 30 minutes and he didn't really feel it. And also alterations in self, where some people saying that, for example, they felt that they were part of everything. And then another participant said that he compared his experience to an out-of-body experience that he had before, where he said that during the experience, I disappeared. I didn't understand. I'm sitting here. It's as if I'd left my body. So that was really interesting for us. And another participant said that we sort of gave people like a problem, or told them to think about a question. It might be psychological, work-related, whatever, that they would like to solve. And one participant said after the experience that while he didn't solve his problem, he felt that the experience helped him find new perspectives, perhaps implying that maybe it's possible to sort of gain insights through this type of experiences as well. And also, interestingly, we found that people who had more psychedelic and meditative experience got a lot lower results. But what all of them said afterwards was that they were sort of expecting, they had high expectations of this experience to be like very similar to a psychedelic experience. So that is something that has to be taken into account in the design, as well as that is something that anyways, that has to be taken account in the design of the experiments. And so there were multiple limitations. I will just go through a couple of them. One of them is that we really did the experiments with a very early version of the virtual reality. So there were a couple of technical issues with it, but most people weren't bothered by it. But a couple of people did say that it sort of broke their immersion. And also our measurements are really mainly qualitative right now. Only the MEQ30 is the only quantitative measure. And also the setting was a very sterile laboratory setting. It wasn't very, unlike the setting that is used in contemporary psychedelic therapy, where the setting is a very important factor and the setting is very cozy, almost, mystical in itself. And we had a very sterile setting. So these are all things that we're looking to change in a couple of weeks, where we're starting new sets of experiments with this virtual reality. Thanks a lot for listening. It's been great to be here, and if you have any questions, then please.
Thank you so much. What an interesting talk. We've got a few questions, but only time for one, I'm afraid. But of course, follow them up as you wish, Kristjan, in the chat. I'm going to ask Matilda's question, which is, she says, I've read and heard about psychedelics. Some of the big impacts of psychedelic use have been in mental states and lasting worldview changes, as well as the perceptual experiences. How does the VR situation or experiences account for that?
1 second. I would like to read the question, but I'm not sure if I can find it.
I can repost it.
I'm not sure. I have a lot of screens on my computer, so I'm not sure if I can find the the window with the question.
Sharing your screen, it will be a lot easier to find. Unfortunately, this is just how Zoom works.
That's a great great point. Now it wants to share one more here. Yeah, just a second. Yeah, I mean, I think the what do you mean? Do you mean sort of like before or after? I mean, I'm sorry it's taking so long, but I'm really having trouble understanding the question.
That's okay. If you want, you could answer this one directly to Mathilde. I could ask John's question, which is, do you do any work with more than just visual hallucinations? For example, sonic hallucinations, or do you have any plans to go in that direction?
Yeah, definitely. We're using auditory illusions in a way where some of the things that can be used are, I don't remember the names, I think Risset and Bassett hallucinations, where you can sort of make the tempo be infinitely rising. That's, for example, something that we use, and or you can make the pitch be infinitely rising, and also play around with the speed of the sound, making everything very slow and very fast.
Great, thank you so much for your presentation, and I encourage you to answer whatever more questions there are in the chat.
Thank you.
So we're going to be moving on to the next talk, which is from Carla Dance, and Carla is working at the University of Sussex, and her talk is going to be on what is the link between mental imagery and sensory sensitivity, insights from aphantasia. So when you're ready, Carla, you can start sharing your screen.
Thank you. 1 second. So I have pre-recorded my talk today just to try and save some network issues and to make sure that it does fit within the 8 minutes. I'm just going to grab it up now. 1 second. Share my screen. Okay. Yeah, so I'm Carla Dance. I'm a PhD student within the Leverhulme doctoral scholarship program here at Sussex. I work in Professor Giulia Simner's lab, and my research focuses on mental imagery and in particular aphantasia. And if you don't know what that is, I'm going to introduce it within the talk. So I'll just press play now, and I'll be happy to answer any questions at the end.
We might have some issues with the sound coming through, so maybe make sure that when you shared the screen that you ticked share sounds just in the bottom left-hand corner of the share screen dialog.
Okay, so can you hear it now? So today I'm going to give a talk about one of our recent projects which looked at the relationship between sensory mental. Is that okay?
Yeah, brilliant.
Brilliant, thank you. So today I'm going to give a talk about one of our recent projects which looked at the relationship between sensory mental imagery and sensory sensitivity. So my current research is interested in visual mental imagery, which is the ability to see a picture in your mind. For example, if I ask you all to imagine a sunset, most of you would see a picture in your mind that looks like a sunset in real life. And mental imagery encompasses the other senses too. For example, being able to hear a song in your head in auditory imagery. Importantly to our research, people differ in how vivid or strong their sensory mental images are. Some people have very strong mental images that are nearly as vivid as real life, whereas others have much weaker levels of imagery. But as well as differing in the vividness of image sensory information, people also differ in how incoming sensory information from the outside world makes them feel. And some people are particularly sensitive to incoming sensory information, and this is known as sensory sensitivity. And sensory sensitivity can be experienced in terms of hyper and hyposensitivity. So somebody who is visually hypersensitive might seek to avoid bright lights, whereas someone who is visually hyposensitive might be unaware or unresponsive to bright lights. And people experience sensory sensitivities across the different senses. Our main research question in this project was whether the way we image sensory information, our mental imagery, maps onto the way we experience or perceive sensory information in the real world, our sensory sensitivity. So for example, if someone has low mental imagery, is their sensory sensitivity also low? So to examine this research question, we elicited responses from people with aphantasia. And aphantasia is a lifelong condition in which visual imagery is absent or weak, so it might be extremely dim and vague. So when asked to imagine a sunset, people with aphantasia would not experience an image in their mind, or they'd see an image that's very dim and vague, such as the image shown here. In this project, we asked whether the imagery weakness in aphantasia extends into the other non-visual senses. If so, we could use aphantasia to answer questions about the relationship between mental imagery and sensory sensitivity. So our first research question then was whether the imagery weakness in aphantasia extends beyond the visual sense. So in our study, a group of aphantasics and a group of imaging control, so people who have visual imagery, completed a range of questionnaires online which measured imagery across the senses. So the top 5 questionnaires seen here measured imagery in each of the senses, and the Plymouth Sensory Imagery Questionnaire measured imagery again in each of the senses. And we used the Vividness of Visual Imagery Questionnaire to help us categorise people as aphantasics or controls. So we found that aphantasics in dark grey on the graphs reported weaker imagery across all senses tested compared to controls who are in light grey. And we saw this for both lots of questionnaires. So given this, we next looked at whether the imagery weaknesses experienced by the aphantasic group were extreme enough to be considered aphantasia-like. So was their imagery in these other senses absent or dim and vague? And we found that nearly all of our aphantasic group reported aphantasia-like imagery in at least one other non-visual sense, compared to 11% of our controls. 62% of the aphantasics had imagery that was aphantasia-like across all of the senses tested, compared to none of our controls. And approximately a third of the aphantasic group reported no imagery whatsoever in any of the senses tested, compared to none of the controls. So these results show then that the imagery weakness in aphantasia does often extend beyond the visual sense. So next we asked whether aphantasics might also be lower in sensory sensitivity. And to examine this question, we use both self-report and behavioural methods. So in this part of the study, the same group of participants who completed the imagery questionnaires completed the Glasgow Sensory Questionnaire, which measures sensory sensitivity across multiple senses. And participants also completed the Autism Spectrum Quotient. And this is a questionnaire that measures traits associated with autism spectrum conditions. And it was important to factor out autistic traits because sensory sensitivities are particularly characteristic of people with autism or high autistic traits. And people with aphantasia, we know from previous research, tend to score higher in autistic traits than people with visual imagery. So we found then, when factoring out the influence of autistic traits, that aphantasics reported fewer sensory sensitivities overall than controls. And we found that aphantasics, again in dark grey on the graph, reported fewer hyper and hyposensitivities compared to the controls. And when looking at each sense individually, we again found that aphantasics were reporting fewer sensory sensitivities in nearly all of the senses tested compared to our controls. So these findings show then that aphantasics seem to be less sensory sensitive than people with visual imagery. And this shows for the first time that mental imagery and sensory sensitivity seem to be linked. So with these findings in mind, we next look to provide some behavioural evidence for lower sensory sensitivity in aphantasia. So in another part of our study, a new group of aphantasics and imaging controls completed a pattern glare task, which is a behavioural measure of sensory sensitivity. So in this task, 3 types of images, also known as gratings, made up of stripy parallel lines, were shown to participants, each shown twice in a random order. Importantly, 2 of the images were designed to elicit visual sensitivity, and these are the medium and the high spatial frequency gratings. And the other, the low spatial frequency grating, was used as a baseline or control grating. So this grating was not designed to elicit any visual sensitivity. So to give an example, here's an example of the low spatial frequency grating, so the baseline grating. So after viewing the grating for 5 seconds, participants then asked questions about their visual sensitivity. So they were asked about any visual discomfort they might have experienced and also any visual effects when viewing the grating. And lastly, the vividness of visual imagery questionnaire was again used to help categorize people as aphantasics or controls. So first, looking at the levels of visual discomfort, in the graph, scores above 0 indicate visual comfort, whereas scores below 0 indicate visual discomfort. So we found that aphantasics, again in dark grey, experienced less discomfort in response to the irritable gratings compared to controls in light grey. And this was significant for the high spatial frequency grating. So these results are showing then that aphantasics seem to be experiencing less sensory sensitivity than our controls. So now looking at the levels of visual effects, we found that aphantasics, again in dark grey, reported fewer visual effects in response to both irritable gratings, the medium and the high, compared to controls. So again, suggesting that aphantasics are experiencing fewer sensory sensitivities. So these results show then that aphantasics seem to be less sensory sensitive than people with visual imagery, providing further support for imagery and sensory sensitivity being linked. So an overall summary now then, our study shows that the imagery weakness in aphantasia often extends beyond the visual sense. Here we've also shown that people with aphantasia tend to be less sensory sensitive than people with visual imagery. So for the first time, these results show that the way we image sensory information might be linked to the way we experience or perceive sensory information in the real world. So why might imagery and sensory sensitivity be linked? Our results may support a model where imagery and sensory sensitivity are linked via levels of excitation in the visual cortex. And this is because both low visual imagery and low visual sensory sensitivity have been linked independently to low visual cortex excitation in previous research. So aphantasics might be characterized by lower levels of visual cortex excitation, and examining this will be an interesting avenue for future research. For now, we provide the first evidence for mental imagery and sensory sensitivity being linked. Thanks very much for listening. A huge thanks to my supervisor, Professor Simner, to our lab and our collaborators, and also to our funders, the Leverhulme Trust. Thanks very much.
Thanks, Carla. That was great. We have only one question at the moment. So we've got one here from Rennie who says, what is the evidence that aphantasia extends beyond inability to report experience?
So if I understand correctly, you're asking whether it's just to do with the fact that they're not reporting it accurately. So perhaps they have imagery and they're not reporting it. Is that correct? Before I answer. Yeah. So there's some behavioural and neural evidence for aphantasia kind of being a real condition, if you like. So there's evidence from Pearson's lab in Australia, which used kind of a binocular rivalry task to measure aphantasia. So, for example, participants are asked to imagine one of two gratings, and then if you've got strong visual imagery, what tends to happen is that grating then becomes dominant. And what you find in aphantasia is that effect doesn't seem to exist. And there's also kind of a bunch of imaging studies coming out now showing that does seem to be kind of a neural basis of aphantasia. And what seems to be happening is there's sort of like a bit of a lack of connectivity between the frontal parts of the brain, sort of the top down areas, which might be controlling imagery in a sense, and the sort of visual areas at the back of the brain. Because it's such a new area of research, we don't have all the answers for this yet, but it seems to be that people with aphantasia are actually very accurate at reporting their imagery abilities. And it's just that they don't have imagery, or they have very poor imagery indeed.
Thanks for the answer. We've got another question here from Zoltan, who asks, is the lower hyposensitivity predicted by your model?
Yeah, so interestingly, what you tend to find is if somebody reports high levels of hypersensitivities, they also tend to report high levels of hyposensitivities. What we're thinking is it's linked via kind of adaptation. So if you're hyper responsive to something, say something's very bright in your visual field or it's a loud noise, you might then become underreactive to other things around you. So there's sort of this link between hyper and hyposensitivities, which on the face of it, you wouldn't think necessarily would be related, but this is sort of what we think is happening, or what could be happening.
Great. I think we have time for one more question. Yeah. So we've got a question from Mathilde, who asks, is there a relationship between aphantasia and, I can't pronounce this.
Prosopagnosia, I think, if I just read it in the chat. Yeah.
There you go. Thank you. Thanks.
There's a really interesting question because in previous literature, it's been shown that people with prosopagnosia tend to have lower visual imagery. And we know from self-report in some of Adam Zeman's studies that people with aphantasia tend to score higher in the prosopagnosia index, so tend to be reporting high levels of not being able to recognize faces. And we're running a study at the moment actually that's looking at this in more detail. So we're looking at face memory in aphantasia and also the ability to build face composites, so using sorts of eFit softwares. So we're looking at how imagery and aphantasia play into these things at the moment. So hopefully we'll have some results on that very soon.
Thanks. And we've got another one. We've got another question, I think. Okay, we're out of time apparently. Thank you so much for your talk, Carla. We're going to go on to the last student presentation. But yeah, there's a lot of questions for you in the chat, so feel free to answer them.
Thanks very much.
Great, thank you both. That kind of concludes our PhD presentation talks. Thank you everybody for coming today for the day 2 of our Sensation Sussex Conference. So yeah, thank you very much for coming. You can we're in the process of getting consent from our speakers to put the videos up on YouTube. So everyone who's registered on Eventbrite will get an email if that's the case. I'm just going to hand over to Anil and Jamie to make some closing remarks.
Cool. I'm not sure. Can you hear me? Yeah, I hope you can hear me.
Great.
I'm not sure if Jamie's here. Basically, I just wanted to repeat what I said yesterday, which is thank you for an amazing job in organizing this, putting this on. Just for the people in the audience, I said this yesterday too. Jamie and I co-direct the program, but we really did not organize this conference. This was completely student-led as advertised. They did absolutely everything, and it's been a real joy to see it come together over the last 2 days. And they were able to handle even a couple of glitches behind the scenes with grace and fluency, so that everything continued to run smoothly, which is you know, quite impressive, because these things are not so easy. And the easier they look, the harder they often are behind the scenes. So thank you to everybody for that. I'm going to steal a little sort of finishing privilege here just to advertise. There is a postdoc job available at the University of Sussex. Just been advertised now. It's kind of relevant to the themes we've been talking about. It's to work with me, David Schwartzman and Fiona McPherson in Glasgow to look at studying individual differences in perception in a large-scale surveys across the country as part of a big art science project that's rolling out next year. And both Jamie and Jules, I think, will also be involved, as many of the other people who've been on the scheme might also be involved in this project too. So if you're interested in this postdoc, it's applications close on the October 22nd. But main thing is to say thank you to everybody for coming and staying for all the presentations. Thank you to the speakers, but again, most of all, thank you to the Leverhulme students for putting this on.
Well done.
We look forward to buying you some dinner and drinks very shortly. Well-deserved dinner and drinks. That's all, folks, I think, right?
Thank you, everybody.